5, where it is said that Josiah put down the idolatrous priests, them also that burned incense unto Baal, to the sun, and to the moon, and to the planets, Mazaloth, and to all the host of heaven. The context itself, as well as the parallel passage in Deuteronomy, when thou sayest the sun, and the moon, and the stars, even all the host of heaven, shouldst be driven to worship them, shows clearly that celestial luminaries of some kind are intended, probably certain groups of stars, distinguished from the general host of heaven. Comparing Job 9:9 with Job 38:31-32, we find Ash or Aish, Kema and Kezel common to the two passages. If we take Ash and Aish as identical, this leaves the chambers of the south as the equivalent of Mazaroth. The same expression occurs in the singular in Job 37:9, out of the south Marg chamber, cometh the whirlwind. There need be but little question as to the significance of these various passages. The correspondence of the word Mazaroth with the Babylonian Mizrata, the divisions of the year, answering to the 12 signs of the zodiac, points in exactly the same direction as the correspondence in idea which is evident between the chambers of the south and the Arabic al-manazil, the mansions, or resting places, of the moon in the lunar zodiac. Mazaroth are therefore the divisions of the zodiac, the chambers through which the sun successively passes in the course of the year, his resting place for a month. They are the chambers of the south, since that is their distinctive position. In Palestine, the sun, even at rising or setting at midsummer, passes but little to the north of east or west. Roughly speaking, the south is the sun's quarter, and therefore it is necessarily the quarter of the constellation in which the sun is placed. It has been made an objection to this identification that the Israelites are said to have worshipped Mazaloth, and we have no direct evidence that the signs or constellations of the zodiac were worshipped as such. But this is to make a distinction that is hardly warranted. The creation tablets, as we have seen, distinctly record the allocation of the great gods to the various signs, Merodach himself being one of the three deities associated with the month Adar, just as in Egypt a god presided over each one of the 36 decades of the year. Again, it is probable that the golden calf, worshipped by the Israelites in the wilderness, and, after the disruption, at Bethel and at Dan, was none other than an attempt to worship Jehovah under the symbol of Taurus, the leader of the zodiac and cognizance of the tribe of Joseph, regarded as a type of him who had been the leader of the people out of Egypt, and the giver of the blessings associated with the return of the sun to Taurus, the revival of nature in springtime. It was intended as a worship of Jehovah. It was in reality dire rebellion against him, and a beginning of the worship of Mazaloth and the heavenly host, an idolatry that was bound to bring other idolatries in its train. A threefold symbol found continually on Babylonian monuments, the triad of stars, undoubtedly at one time set forth Sin, the moon god, Samus, the sun god, and Ishtar, in this connection possibly the planet Venus. It has therefore been suggested by Professor Schiaparelli that Mazaloth is the planet Venus, and, since the word is plural in form, Venus in her double capacity, sometimes an evening, sometimes a morning star. The sun and the moon and Mazaloth would then set forth the three brightest luminaries, whilst the general congress of stars would be represented by the host of heaven. But though Venus is sometimes the brightest of the planets, she is essentially of the same order as Jupiter or Mars, and is not of the same order as the sun and moon, with whom, on this supposition, she is singled out to be ranked. Moreover, if Ishtar or Ashtoreth were intended in this passage, it does not appear why she should not be expressly named as such, especially as Baal, so often coupled with her, is named. The triad of stars, too, had originally quite a different meaning, as will be seen later. Moreover, the parallelism between Job 9 and Job 38 is destroyed by this rendering, since the planet Venus could not be described as the chambers of the south. These are therefore referred by Professor Schiaparelli to the glorious mass of stars in the far south, shining in the constellations that set forth the deluge story, the ship, and the centaur, much the most brilliant region of the whole sky. Another interpretation of Mazaroth is given by Dr. Shane, on grounds that refute Professor Schiaparelli's suggestion, but it is itself open to objection from an astronomical point of view. He writes, Mazzaroth is probably not to be identified with Mazaloth, 2 Kings 23. 5, in spite of the authority of the September and the Targum. Mazzaroth equals as. Maserati, Mazaloth, i.e. the zodiacal signs, seems to be the plural of Mazala equals as. Manzaltu, station. 254:1, Dr. Shane therefore renders the passage thus, Dost thou bring forth the moon's watches at their season, and the bear and her offspring, dost thou guide them? Knowest thou the laws of heaven? Dost thou determine its influence upon the earth? Mazaloth are therefore, the zodiacal signs, but Mazzaroth, the watches or stations of the moon, which mark the progress of the month, 254:2, or, in other words, the lunar zodiac. But the lunar and the solar zodiac are only different ways of dividing the same belt of stars. Consequently when, as in the passage before us, reference is made to the actual belt of stars as a whole, there is no difference between the two. So that we are obliged, as before, to consider Mazzaroth and Mazaloth as identical, and both as setting forth the stars of the zodiac. So far as the two zodiacs differ, it is the solar and not the lunar zodiac that is intended. This is evident when we consider the different natures of the apparent motions of the sun and the moon. The sun passes through a 12th part of the zodiac each month, and month by month the successive constellations of the zodiac are brought out, each in its own season, each having a period during which it rises at sunset, is visible the whole night, and sets at sunrise. The solar Mazzaroth are therefore emphatically brought out, each in its season. Not so the lunar Mazzaroth. The expression, the watches or stations of the moon which mark the progress of the month, is unsuitable when astronomically considered. Watches refer strictly to divisions of the day and night, the stations of the moon refer to the 27 or 28 divisions of the lunar zodiac, the progress of the month refers to the complete sequence of the lunar phases. These are three entirely different matters, and Dr. Shane has confused them. The progress of the moon through its complete series of stations is accomplished in a sidereal month, that is, 27 days 8 hours, but from the nature of the case it cannot be said that these stations are brought out each in his season, in that time, as a month makes but a small change in the aspect of the sky. The moon passes through the complete succession of its phases in the course of a synodical month, which is in the mean 29 days, 13 hours, that is to say from new to new, or full to full, but no particular star, or constellation, or station, has any fixed relation to any one given phase of the moon. In the course of some 4 or 5 years the moon will have been both new and full in every one of the lunar stations. Knowest thou the ordinances of heaven? Canst thou set the dominion thereof in the earth? He, who has lived out under the stars, in contact with the actual workings of nature, knows what it is to watch Mazzaroth, brought out in his season, the silent return to the skies of the constellations, month by month, simultaneous with the changes on the face of the earth. Overhead, the glorious procession, so regular and unfaltering, of the silent, unapproachable stars, below, in unfailing answer, the succession of spring and summer, autumn and winter, seed-time and harvest, cold and heat, rain and drought. If there be but eyes to see, this majestic order, so smooth in working, so magnificent in scale, will impress the most stolid as the immediate acting of God, and the beholder will feel at the same a reverent awe, and an uplifting of the spirit as he sees the action of the ordinances of heaven, and the evidence of the dominion thereof in the earth. Dr. Shane, however, only sees in these beautiful and appropriate lines the influence upon the sacred writer of the Physical Theology of Babylonia, Winkwithafrown 256:1, in other words, its idolatrous astrology, the influence of the sky upon the earth. But what would Job understand by the question, canst thou bring forth Mazzaroth in his season? Just this. Canst thou so move the great celestial sphere that the varied constellations of the zodiac shall come into view, each in their turn, and with them the earth pass through its proper successive seasons? The question therefore embraced and was an extension of the two that preceded it. Canst thou bind the sweet influences of the Pleiades? Canst thou prevent the revival of all the forces of nature in the springtime, and canst thou loose the bands of Orion, canst thou free the ground from the numbing frosts of winter? The question to us would not greatly differ in its meaning, except that we should better understand the mechanism underlying the phenomena. The question would mean, canst thou move this vast globe of the earth, weighing 6,000 million times a million tons, continually in its orbit, more than 580 millions of miles in circuit, with a speed of nearly 19 miles in every second of time, thus bringing into view different constellations at different times of the year, and presenting the various zones of the earth in different aspects to the sun's light and heat? To us, as to Job, the question would come as, knowest thou the ordinances of heaven? Canst thou set the dominion thereof in the earth? It is going beyond astronomy, yet it may be permitted to an astronomer, to refer for comparison to a parallel thought, not couched in the form of a question, but in the form of a prayer, Thy will be done, as in heaven, so in earth. Footnotes, 254:1, Rev. T. K. Shane, M.A., Job and Solomon, page 290. 254:2, Ibid, page 52. 256:1, Rev. T. K. Shane, M.A., Job and Solomon, page 52. Chapter 9 Arcturus. In two passages of the book of Job a word, Ash or Aish, is used, by context evidently one of the constellations of the sky, but the identification of which is doubtful. In our authorized version the first passage is rendered thus, God, which mocketh Arcturus, Ash, Orion, and Pleiades, and the chambers of the south, and the second, canst thou bind the sweet influences of Pleiades, or loose the bands of Orion? Canst thou bring forth Mazzaroth in his season? Or canst thou guide Arcturus, Aish, with his sons? Knowest thou the ordinances of heaven? Canst thou set the dominion thereof in the earth? The words, or word, for possibly Aish is no more than a variant of Ash, here translated Arcturus, were rendered by the 70 as Arcturos in the first passage, as Hesperos in the second passage, and their rendering was followed by the Vulgate. The rendering Hesper or Vesper is absurd, as the sons of Hesper has no meaning. Arcturos is not improbably a misrendering of Arctos, the north, which would give a free but not a literal translation of the meaning of the passage. In another passage from Job, 37:9, where the south wind is contrasted with the cold from another quarter of the sky, the 70, again followed by the Vulgate, rendered it as cold from Arcturus. Now cold came to the Jews, as it does to us, from the north, and the star which we know as Arcturus could not be described as typifying that direction either now or when the Septuagint or Vulgate versions were made. The Peshitta, the Syriac version of the Bible, made about the 2nd century after Christ, gives as the Syriac equivalent for Ash, or Aish, the word Iotha, but it also renders Kezel by the same word in Amos v. 8, so that the translators were evidently quite at sea as to the identity of these constellations. We are also in doubt as to what star or constellation the Syrians meant by Iotha, and apparently they were in some doubt themselves, for in the Talmud we are told that there was a disputation, held in the presence of the great teacher Rabbi Jehuda, about 150 years after Christ, whether Iotha was situated in the head of the bull, or in the tail of the ram. Oriental scholars now assign it either to Aldebaran in the head of the bull, the sons being in this case the other members of the Hyades group of which Aldebaran is the brightest star, or else identifying it with the Arabic Eliak, the name of the star which the Greeks call Ix, and we call Capella, the sons, on this inference being the three small stars near, called by the Greeks and by ourselves the kids. The word Ash is used several times in Scripture, but without any astronomical signification, and is there rendered moth, as in Isaiah, where it says, Lo, they all shall wax old as a garment, the moth, Ash, shall eat them up. This literal significance of the word does not help, as we know of no constellation figured as a moth or bearing any resemblance to one. But the word Ash or Aish does not differ importantly from the word Naash in Hebrew, assembly, in Arabic, bir, which has been the word used by the Arabs from remote antiquity to denote the four bright stars in the hindquarters of the Great Bear, those which form the body of the plough. Moreover, the three stars which form the tail of the Great Bear, or the handle of the plough, have been called by the Arabs Banat Naash, the daughters of Naash. The Bear is the great northern constellation, which swings constantly round the pole, always visible throughout the changing seasons of the year. There should be no hesitation then in accepting the opinion of the Rabbi, Ibn Ezra, who saw in Ash, or Aish, the quadrilateral of the Great Bear, whose 4 points are marked by the bright stars, Alpha, Beta, Gamma and Delta, and in the sons of Aish, the 3 stars, Epsilon, Zeta, and Eta. Our revised version therefore renders the word as bear. In both passages of Job, then, we get the 4 quarters of the sky marked out as being under the dominion of the Lord. In the 9th chapter they are given in the order: the Bear, which is in the north, Orion, in its acronical rising, with the sun setting in the west, the Pleiades, in their heliacal rising, with the sun rising in the east, and the chambers of the south. In the later passage they are given with fuller illustration, and in the order: the Pleiades, whose sweet influences are given by their heliacal rising in springtime, with the sun rising in the east; Orion, whose bands are those of winter, heralded by his acronical rising with the sun setting in the west; Mazzaroth, the constellations of the zodiac corresponding to the chambers of the south, which the sun occupies each in its season. The Bear with its sons, who, always visible, are unceasingly guided round the pole in the north. The parallelism in the 2 passages in Job gives us the right to argue that Ash and Aish refer to the same constellation, and are variants of the same name. Possibly their vocalization was the same, and they are but 2 divergent ways of writing the word. We must therefore reject Professor Schiaparelli's suggestion made on the authority of the Peshitta version of the scriptures and of Rabbi Jehuda, who lived in the 2nd century A.D., that Ash is Iutha, which is Aldebaran, but that Aish and his sons may be Capella and her kids. Equally we must reject Professor Stern's argument that Kima is Sirius, Kezel is Orion, Mazzaroth is the Hyades and Aish is the Pleiades. He bases his argument on the order in which these names are given in the 2nd passage of Job, and on the contention of Ottfried Müller that there are only 4 out of the remarkable groups of stars placed in the middle and southern regions of the sky which have given rise to important legends in the primitive mythology of the Greeks. These groups follow one after the other in a belt in the sky in the order just given, and their risings and settings were important factors in the old Greek meteorological and agricultural calendars. Professor Stern assumes that Kezel means Orion, and from this identification deduces the others, neglecting all etymological or traditional evidences to the contrary. He takes no notice of the employment of the same names in passages of Scripture other than that in the 38th chapter of Job. Here he would interpret the chain, or sweet influences, of Kima equals Sirius the dog, by assuming that the Jews considered that the dog was mad, and hence was kept chained up. More important still, he fails to recognize that the Jews had a continental climate in a different latitude from the insular climate of Greece, and that both their agricultural and their weather conditions were different, and would be associated with different astronomical indications. In the 9th verse of the 37th chapter of Job we get an antithesis which has already been referred to: out of the south cometh the whirlwind, and cold out of the north. The Hebrew word here translated north is Mezarim, a plural word which is taken literally to mean the scatterings. For its interpretation Professor Schiaparelli makes a very plausible suggestion. He says, we may first observe that the 5 Hebrew letters with which this name was written in the original unpointed text could equally well be read, with a somewhat different pointing, as Mizraim, or also as Mizraim, of which the one is the plural, the other the dual, of Mizraim. Now Mizraim means a winnowing fan, the instrument with which grain is scattered in the air to sift it, and it has its root, like Mezarim, in the word Zara, which, besides the sense disperse it, bears also the sense expand it, ventilate it. 263:1, Stars of the Plough. Stars of the plough, as the winnowing fan. To list if Professor Schiaparelli is correct in his supposition, then the word translated, north, in our versions is literally the 2 winnowing fans, names which from the form suggested by the stars we may suppose that the Jews gave to the 2 bears in the sky, just as the Chinese called them the ladles, and the Americans call them the Big Dipper and the Little Dipper. The sense is still that of the north, but we may recognize in the word employed another Jewish name of the constellation, alternative with Ash or Aish, or perhaps used in order to include in the region the Lesser as well as the Greater Bear. We should not be surprised at finding an alternative name for this great northern constellation, for we ourselves call it by several different appellations, using them indiscriminately, perhaps even in the course of a single paragraph. What to Job did the question mean which the Lord addressed to him, "Canst thou guide the bear and his sons?" To Job it meant, "Canst thou guide this great constellation of stars in the north, in their unceasing round, as a charioteer guides his horses in a wide circle, each keeping to his proper ring, none entangling himself with another, nor falling out of his place." What would the same question mean to us, if addressed to us today? In the first place we might put it shortly as, "Canst thou turn the earth on its axis regularly and continuously, so as to produce this motion of the stars round the pole, and to make day and night?" But modern astronomy can ask the question in a deeper and a wider sense. It was an ancient idea that the stars were fixed in a crystal sphere, and that they could not alter their relative positions, and indeed until the last century or two, instruments were not delicate enough to measure the small relative shift that stars make. It is within the last 70 years that we have been able to measure the annual parallax of certain stars, that is, the difference in the position of a star when viewed by the Earth from the opposite ends of a diameter of the Earth's orbit round the Sun. Besides their yearly shift due to annual parallax, most stars have a proper, or peculiar motion, of their own, which is in most cases a very small amount indeed, but can be determined more easily than annual parallax, because its effect accumulates year after year. If, therefore, we are able to observe a star over a period of 50, or 100 or more years, it may seem to have moved quite an appreciable amount when examined by the powerful and delicate instruments that we have now at our disposal. Observations of the exact positions of stars have been made ever since the founding of Greenwich Observatory, so that now we have catalogues giving the proper motions of several hundreds of stars. When these are examined, it is seen that some groups of stars move in fellowship together through space, having the same direction, and moving at the same rate, and of these companies the most striking are the stars of the plough, that is, Aish and his sons. Not all the stars move together. Out of the 7, the first and the last have a different direction, but the other 5 show a striking similarity in their paths. And not only are their directions of movement, and the amounts of it, the same for the 5 stars, but spectroscopic observations of their motion in the line of sight show that they are all approaching us with a speed of about 18 miles a second, that is to say with much the same speed as the Earth moves in her orbit round the Sun. Another indication of their family likeness is that all their spectra are similar. A German astronomer, Dr. Hoffler, has found for this system a distance from us so great that it would take light 192 years to travel from them to us. Yet so vast is this company of 5 stars that it would take light 70 years, traveling at the rate of 186,000 miles in every second of time to go from the leading star, Merak, Beta of the Bear, to Mizar, Zeta of the Bear, the final brilliant of the 5. So bright and great are these suns that they shine to us as gems of the second magnitude, and yet if our sun were placed amongst them at their distance from us he would be invisible to the keenest sight. Dr. Hoffler's estimate may be an exaggerated one, but it still remains true that whilst the cluster of the Pleiades forms a great and wonderful family group, it is dwarfed into insignificance by the vast distances between these 5 stars of the Great Bear. Yet these also form one family, though they are united by no nebulous bands, and are at distances so great from each other that the bonds of gravitation must cease to show their influence, yet all are alike, all are marshalled together in their march under some mysterious law. We cannot answer the question, by what means are Aish and his sons guided? Much more are we speechless when we are asked, canst thou guide them? Footnotes, 263:1, Astronomy in the Old Testament, page 69. Blow up the trumpet in the new moon. Blow up the trumpet in the new moon. To list book 3 times and seasons chapter I. The day and its divisions. There is a difference of opinion at the present day amongst astronomers as to the time in which the planet Venus rotates upon her axis. This difference arises through the difficulty of perceiving or identifying any markings on her brilliantly lighted surface. She is probably continually cloud-covered, and the movements of the very faint shadings that are sometimes seen upon her have been differently interpreted. The older observers concurred in giving her a rotation period of 23 hours 21 minutes, which is not very different from that of the Earth. Many astronomers, amongst them Schiaparelli, assign a rotation period of 225 days, that is to say the same period as that in which she goes round the Sun in her orbit. The axis on which she rotates is almost certainly at right angles to the plane in which she moves round the Sun, and she has no moon. We do not know if the planet is inhabited by intelligent beings, but assuming the existence of such, it will be instructive to inquire as to the conditions under which they must live if this view be correct, and the rotation period of Venus, and her revolution period be the same. Venus would then always turn the same face to the Sun, just as our moon always turns the same face to us and so never appears to turn round. Venus would therefore have no days, for on her one hemisphere there would be eternal light, and on the other eternal darkness. Since she has no moon, she has no month. Since she moves round the Sun in a circle, and the axis through her north and south poles lies at right angles to her ecliptic, she has no seasons, she can have no year. On her daylight side, the Sun remains fixed in one spot in the sky, so long as the observer does not leave his locality. It hangs overhead, or near some horizon, north, south, east, or west, continually. There are no hours, therefore no divisions of time, it might be almost said no time itself. There are no points of the compass even, no north, south, east or west, no directions except towards the place where the Sun is overhead or away from it. There could be no history in the sense we know it, for there would be no natural means of dating. Time must there be artificial, uncertain and arbitrary. On the night side of Venus, if her men can see the stars at all for cloud, they would perceive the slow procession of stars coming out, for Venus turns continually to the heavens, though not to the Sun. Mazzaroth would still be brought out in his season, but there would be no answering change on Venus. Her men might still know the ordinances of heaven, but they could not know the dominion thereof set upon their earth. This imaginary picture of the state of our sister planet may illustrate the 14th verse of the first chapter of Genesis, and God said, "Let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs, and for seasons, and for days, and years." The making of the calendar is in all nations an astronomical problem. It is the movements of the various heavenly bodies that give to us our most natural divisions of time. We are told in Deuteronomy, "The sun, and the moon, and the stars, even all the host of heaven. The Lord thy God hath divided unto all nations under the whole heaven." This is the legitimate use of the heavenly bodies, just as the worship of them is their abuse, for the division of time, in other words, the formation of a calendar, is a necessity. But as there are many heavenly bodies and several natural divisions of time, the calendars in use by different peoples differ considerably. One division, however, is common to all calendars, the day. The day is the first and shortest natural division of time. At present we recognize three kinds of days: the sidereal day, which is the interval of time between successive passages of a fixed star over a given meridian; the apparent solar day, which is the interval between two passages of the Sun's center over a given meridian, or the interval between two successive noons on a sundial; and the mean solar day, which is the interval between the successive passages of a fictitious sun moving uniformly eastward in the celestial equator, and completing its annual course in exactly the same time as that in which the actual sun makes the circuit of the ecliptic. The mean solar days are all exactly the same length, they are equal to the length of the average apparent solar day, and they are each 4 minutes longer than a sidereal day. We divide our days into 24 hours, each hour into 60 minutes, each minute into 60 seconds. This subdivision of the day requires some mechanical means of continually registering time, and for this purpose we use clocks and watches. The sidereal day and the mean solar day necessitate some means of registering time, such as clocks, therefore the original day in use must have been the apparent solar day. It must then have been reckoned either from sunset to sunset, or from sunrise to sunrise. Later it might have been possible to reckon it from noon to noon, when some method of fixing the moment of noon had been invented, some method, that is to say, of fixing the true north and south, and of noting that the sun was due south, or the shadow due north. Our own reckoning from midnight to midnight is a late method. Midnight is not marked by the peculiar position of any visible heavenly body, it has, in general, to be registered by some mechanical time measurer. In the Old Testament scriptures the ecclesiastical reckoning was always from one setting of the sun to the next. In the first chapter of Genesis the expressions for the day's run, the evening and the morning, as if the evening took precedence of the morning. When the Passover was instituted as a memorial feast, the command ran, in the first month, on the 14th day of the month at even, ye shall eat unleavened bread, until the 21st day of the month at even. 7 days shall there be no leaven. And again, for the Sabbath of rest in the 7th month, in the 9th day of the month at even, from even unto even, shall ye celebrate your Sabbath. The ecclesiastical day of the Jews, therefore, began in the evening, with sunset. It does not by any means follow that their civil day began at this time. It would be more natural for such business contracts as the hiring of servants or laborers to date from morning to morning rather than from evening to evening. Naturally any allusion in the scriptures to the civil calendar as apart from the ecclesiastical would be indirect, but that common custom was not entirely in agreement with the ecclesiastical formula we may perhaps gather from the fact that in the Old Testament there are 26 cases in which the phrases day and night, day or night, are employed, and only 3 where night comes before day. We have a similar divergence of usage in the case of our civil and astronomical days, the first beginning at midnight, and the second at the following noon, since the daylight is the time for work in ordinary business life, but the night for the astronomers. The Babylonians, at least at a late date in their history, had also a twofold way of determining when the day began. Epping and Strassmayer have translated and elucidated a series of Babylonian lunar calendars of dates between the 1st and 2nd centuries before our era. In one column of these was given the interval of time which elapsed between the true new moon and the first visible crescent. Curious to relate, at first all Father Epping's calculations to establish this result were out by a mean interval of 6 hours. The solution was found in the fact that the Babylonian astronomers were not content with such a variable instant of time as sunset for their calculations, as indeed they ought not to have been, but used as the origin of the astronomical day at Babylon the midnight which followed the setting of the sun, marking the beginning of the civil day. It may be mentioned that the days as reckoned from sunset to sunset, sunrise to sunrise, and noon to noon, would give intervals of slightly different lengths. This would, however, be imperceptible so long as their lengths were not measured by some accurate mechanical time measure such as a clepsydra, sandglass, pendulum, or spring clock. The first obvious and natural division of the whole day interval is into the light part and the dark part. As we have seen in Genesis, the evening and the morning are the day. Since Palestine is a subtropical country, these would never differ very greatly in length, even at midsummer or midwinter. The next subdivision, of the light part of the day, is into morning, noon and evening. As David says in the 55th Psalm, evening, and morning, and at noon, will I pray. None of these 3 subdivisions were marked out definitely in their beginning or their ending, but each contained a definite epoch. Morning contained the moment at which the sun rose, noon the moment at which he was at his greatest height, and was at the same time due south, evening contained the moment at which the sun set. In the early scriptures of the Old Testament, the further divisions of the morning and the evening are still natural ones. For the progress of the morning we have, first, the twilight, as in Job, let the stars of the twilight thereof be dark, let it look for light but have none, neither let it see the eyelids of the morning. Then, daybreak, as in the Song of Solomon, until the day break, literally, breathe, and the shadows flee away, where the reference is to the cool breezes of twilight. So too in Genesis, in Joshua, in the Judges and in Samuel, we find references to the break of day, literally, the rising of the morning, or when it became light to them, and the dawning of the day, or about the spring of the day. The progress of the morning is marked by the increasing heat, thus as the sun waxed hot, the manna melted, whilst Saul promised to let the men of Jabesh Gilead have help, by that time the sun be hot, or, as we should put it, about the middle of the morning. Noon is often mentioned. Ishbosheth was murdered as he lay on a bed at noon, and Jezebel's prophets called on the name of Baal from morning even unto noon. We find the afternoon, lit till the day declined, mentioned in the 19th chapter of the Judges, and in the same chapter this period is further described in the day draweth toward evening, lit. Is weak, and the day groweth to an end, lit. It is the pitching time of the day, that is to say, the time for pitching tents, in preparation for the nightly halt. As there was no dividing line between the morning and noontide, neither was there any between the afternoon and evening. The shadows of the night were spoken of as chased away by the cool breezes of the morning, so the lengthening shadows cast by the declining sun marked the progress of the evening. Job speaks of the servant who earnestly desireth the shadow, that is to say, the intimation, from the length of his own shadow, that his day's work was done, and Jeremiah says, the shadows of the evening are stretched out. Then came sundown, and the remaining part of the evening is described in Proverbs, in the twilight, in the evening, in the black and dark night. In a country like Palestine, near the tropics, with the days not differing extravagantly in length from one part of the year to another, and the sun generally bright and shining, and throwing intense shadows, it was easy, even for the uneducated, to learn to tell the time of day from the length of the shadow. Here, in our northern latitude, the problem is a more complex one, yet we learn from the Canterbury Tales, that Englishmen in the time of the Plantagenets could read the position of the sun with quite sufficient accuracy for ordinary purposes. Thus the host of the Tabard Inn, though not a learned man, saw WL, that the bright sun the arc of his artificial day had run afore the part, and half an hour and more, and though he was not depe expert in lore, he wist it was the 28th day of April, that is Messager to May, and saw wel that the shadow of every tree was as in length of the same quantity that was the body erect, that caused it, and therefore by the shadow he toke his wit, that Phoebus, which that shone so clear and bright, degrees was 45 clome on height, and for that day, as in that latitude, it was 10 of the clock, he gon conclude. 277:1, in the latter part of the day there is an expression used several times in Exodus, Leviticus, and Numbers, between the two evenings, which has given rise to much controversy. The lamb of the Passover was killed in this period, so also was the lamb of the first year offered daily at the evening sacrifice, and day by day Aaron was then commanded to light the 7 lamps and burn incense. It is also mentioned once, in no connection with the evening sacrifice, when the Lord sent quails to the children of Israel saying, at even, between the two evenings, ye shall eat flesh. In Deuteronomy, where a command is again given concerning the Passover, it is explained that it is, at even, at the going down of the sun. The Samaritans, the Karaite Jews, and Aben Ezra held the 2 evenings to be the interval between the sun setting and the entrance of total darkness, i.e. between about 6 o'clock and 7 or 7:30. A graphic description of the commencement of the Sabbath is given in Disraeli's novel of O'Roy, and may serve to illustrate this, the original idea of between the 2 evenings. The dead were plundered, and thrown into the river, the encampment of the Hebrews completed. O'Roy, with his principal officers, visited the wounded, and praised the valiant. The bustle which always succeeds a victory was increased in the present instance by the anxiety of the army to observe with grateful strictness the impending Sabbath. When the sun set the Sabbath was to commence. The undulating horizon rendered it difficult to ascertain the precise moment of his fall. The crimson orb sunk below the purple mountains, the sky was flushed with a rich and rosy glow. Then might be perceived the zealots, proud in their Talmudical lore, holding the skein of white silk in their hands, and announcing the approach of the Sabbath by their observation of its shifting tints. While the skein was yet golden, the forge of the armorer still sounded, the fire of the cook still blazed, still the cavalry led their steeds to the river, and still the busy footmen braced up their tents, and hammered at their palisades. The skein of silk became rosy, the armorer worked with renewed energy, the cook puffed with increased zeal, the horsemen scampered from the river, the footmen cast an anxious glance at the fading light. The skein of silk became blue, a dim, dull, sepulchral, leaden tinge fell over its purity. The hum of gnats arose, the bat flew in circling whirls over the tents, horns sounded from all quarters, the sun had set, the Sabbath had commenced. The forge was mute, the fire extinguished, the prance of horses and the bustle of men in a moment ceased. A deep, a sudden, an all-pervading stillness dropped over that mighty host. It was night, the sacred lamps of the Sabbath sparkled in every tent of the camp, which vied in silence and in brilliancy with the mute and glowing heavens. In later times, on account of ritualistic necessities, a different interpretation was held. So Josephus says, so these high priests, upon the coming of their feast which is called the Passover, slay their sacrifices, from the 9th hour till the 11th. 279:1, and the Talmud made the first evening to begin with the visible decline of the sun and the second with sunset, or, the 2 evenings, to last from 3 till about 6. Schiaparelli gives the first evening from sunset until the time that the newly visible lunar crescent could be seen in the twilight sky, or about half an hour after sunset, and the second evening from that until darkness set in, basing his argument on the directions to Aaron to light the lamps, between the 2 evenings, since, he argues, these would not be made to burn in the daylight. Probably in the days of Moses and Aaron the period could not be defined as accurately as this would imply, as the opportunity of seeing the new moon could only come once a month, and we have no evidence of any mechanical time measure being then in use with them. For shorter spaces of time we have the word moment or instant many times mentioned. The words may mean the opening or winking of the eye, the twinkling of an eye, spoken of by St. Paul, in his epistle to the Corinthians, and do not describe any actual duration of time, or division of the day. The only time measure mentioned in the Bible is the dial of Ahaz, which will form the subject of a later chapter. It need only be noted here that, as it depended upon the fall of the shadow, it was of use only whilst the sun was shining, not during cloudy weather, or at night. As the day had 3 main divisions, so had also the night. There were 3 watches, each, like the watches on shipboard, about 4 hours in length. So in the Psalms, the watches, are twice put as an equivalent for the night. The ancient Hebrews would have no difficulty in roughly dividing the night into 3 equal parts, whenever the stars could be seen. Whether they watched Arcturus and his sons, the circumpolar constellations moving round like a vast dial in the north, or the bringing forth of Mazzaroth, the zodiacal constellations, in the south, they would soon learn to interpret the signs of night with sufficient accuracy for their purpose. The first watch of night is mentioned in the Book of Lamentations. Arise, cry out in the night, in the beginning of the watches pour out thine heart like water before the face of the Lord. It was, in the beginning of the middle watch, and they had but newly set the watch, that Gideon and his gallant 300 made their onslaught on the host of the Midianites. It was in the third, the morning watch, that the Lord looked unto the host of the Egyptians through the pillar of fire and of the cloud, and troubled the host of the Egyptians, as they pursued Israel into the midst of the Red Sea. In this watch also, Saul surprised the Ammonites as they besieged Jabesh Gilead, and scattered them, so that 2 of them were not left together. In the New Testament, the Roman method of dividing the night is adopted, viz. into 4 watches. When the disciples were crossing the Sea of Galilee in their little boat, and they had toiled all night in rowing because the wind was contrary, it was in the 4th watch of the night, that Jesus came unto them. There is no mention of any mechanical time measure in the Old Testament, and in only one book is there mention in the English version of the word hour. 5 times it is mentioned in the book of Daniel as the rendering of the Chaldean word sha'ah, which literally means, the instant of time. No mention either is made of the differing lengths of the days or nights throughout the year. At midsummer the day is 14:1/4 hours long, and the night 9 3/4. Job speaks, however, of causing the dayspring to know its place, which may well refer to the varying places along the eastern horizon at which the sun rose during the course of the year. Thus in midwinter the sun rose 28 degrees south of the east point, or half a point south of E.S.E. Similarly in midsummer it rose 28 degrees north of east, or half a point north of E.N.E. 282:1. The Babylonians divided the whole day interval into 12 kasbu, or double hours. Those again were divided into 60 parts, each equal to 2 of our minutes, this being about the time that is required for the disk of the sun to rise or set wholly. The Babylonian kasbu was not only a division of time, but a division of space, signifying the space that might be marched in a kasbu of time. Similarly we find, in the Old Testament, the expression, a day's journey, or 3 days' journey, to express distance, and in the New Testament we find the same idea applied to a shorter distance in the Sabbath day's journey, which was about 2 miles. But the Jews in New Testament times adopted, not the Babylonian day of 12 hours, but the Egyptian of 24. So we find, in the parable of the laborers in the vineyard, mention made of hiring early in the morning, and at the 3rd, 6th, 9th, and 11th hours, and since those hired latest worked for but 1 hour, it is evident that there were 12 hours in the daylight. Our Lord alludes to this expressly in the Gospel according to St. John, where he says, "Are there not 12 hours in the day? If any man walk in the day, he stumbleth not, because he seeth the light of this world. But if a man walk in the night, he stumbleth, because there is no light in him." Footnotes, 277:1, The Man of Law's Prologue, lines 4421 to 4434. 279:1, Josephus, Wars, 6. 9, 3. 282:1, see the diagram on page 363. Chapter 2 The Sabbath and the Week. The present chapter has little, if anything, to do with astronomy, for the week, as such, is not an astronomical period. But the Sabbath and the week of 7 days are so intimately connected with the laws and customs of Israel that it is impossible to leave them out of consideration in dealing with the times and seasons referred to in the Bible. The day, the month and the year are each defined by some specific revolution of one of the great cosmical bodies. There is in each case a return of the earth, or of the earth and moon together, to the same position, relative to the sun, as that held at the beginning of the period. The week stands in a different category. It is not defined by any astronomical revolution, it is defined by the return of the Sabbath, the consecrated day. A need for the division of time into short periods, less than a month, has been generally felt amongst civilized men. Business of state, commercial arrangements, social intercourse, are all more easily carried out, when some such period is universally recognized. And so, what we may loosely term a week, has been employed in many ancient nations. The Aztecs, using a short month of 20 days, divided it into 4 quarters of 5 days each. The Egyptians, using a conventional month of 30 days, divided it into 3 decades, and decades were also used by the Athenians, whose months were alternately of 29 and of 30 days. Hesiod tells us that the days regarded as sacred in his day were the 4th, 14th, and 24th of each month. The 4th and 24th, no grief should pray within thy breast, for holy either day. Pierce on the 4th thy casque, the 14th prize as holy, and, when morning paints the skies, the 24th is best. The Babylonians divided the month somewhat differently, the 7th, 14th, 19th, 21st and 28th days being regarded as Sabbaths. 284:1, the Sabbath enjoined upon the Hebrews was every 7th day. The week as defined by it was a free week, it was tied neither to month nor year, but ran its course uninterruptedly, quite irrespective of the longer divisions of time. It was, therefore, a different conception from that underlying the usages of the Greeks or Babylonians, and, it may be added, a more reasonable and practical one. 4 origins have been assigned for the week. There are those who assert that it is simply the closest possible approximation to the quarter month, the mean month being 29, 1/2 days in length, a quarter month would be 7, 3/8 days, and since fractions of a day cannot be recognized in any practical division of time for general use, the week of 7 days forms the nearest approach to the quarter month that could be adopted. This is undeniably true, but it is far more likely that such an origin would give rise to the Babylonian system than to the Jewish one, for the Babylonian system corrected the inequality of quarter-month and week every month, and so kept the two in harmony, whilst the Hebrew disregarded the month altogether in the succession of his weeks. Next, it is asserted that the Hebrew Sabbath was derived from the Babylonian, and that, it is scarcely possible for us to doubt that we owe the blessings decreed in the Sabbath or Sunday day of rest in the last resort to that ancient and civilized race on the Euphrates and Tigris. 285:1, there are 2 points to be considered here. Did the Babylonians observe their Sabbaths as days of rest, and, were they or the Hebrews the more likely to hand on their observances to another nation? We can answer both these questions. As to the first, a large number of Babylonian documents on tablets, preserved in the British Museum, have been published by Father Strassmayer, and discussed by Professor Schiaparelli. In all there were 2,764 dated documents available for examination, nearly all of them commercial and civil deeds, and covering practically the whole period from the accession of Nebuchadnezzar to the 23rd year of Darius Hystaspes. This number would give an average of 94 deeds for each day of the month. The number actually found for the 4 Sabbaths, i.e. for the 7th, 14th, 21st and 28th days, were 100, 98, 121 and 91 respectively. The Babylonians evidently did not keep these days as days of rest, or of abstinence from business, as the Jews keep their Sabbath, or Christian countries their Sunday. They cannot even have regarded it as an unlucky day, since we find the average of contracts is rather higher for a Sabbath than for a common day. The case is a little different with the 19th day of the month. This, as the 49th day from the beginning of the previous month, was a Sabbath of Sabbaths, at the end of a week of weeks. In this case only 89 contracts are found, which is slightly below the average, though 12 common days show a lower record still. But in most cases the date is written, not as 19, but as 20-1, as if there were a superstition about the number 19. On the other hand, this method of indicating the number may be nothing more than a mode of writing, just as in our Roman numerals, 19, 1 less than XX, is written for 19. The Babylonians, therefore, did not observe these days as days of rest, though they seem to have marked them in the ritual of temple and court. Nor did they make every 7th or every 5th a rest day, for Professor Schiaparelli has specially examined these documents to see if they gave any evidence of abstention from business either on one day in 7 or on one day in 5, and in both cases with a purely negative result. When we inquire which nation has been successful in impressing their particular form of Sabbath on the nations around, the case is clear. We have no evidence of the Babylonians securing the adoption of their sabbatic arrangements by the Persians, Greeks and Parthians who successively overcame them. It was entirely different with the Jews. The Jewish kingdom before the captivity was a very small one compared with its enemies on either side, Assyria, Babylon and Egypt. It was but a shadow even of its former self after the return. And imperial Rome was a mightier power than Assyria or Babylon at their greatest. If ever one state was secure from influence by another on the score of its greater magnitude and power, Rome was safe from any Jewish impress. Yet it is perfectly well known that the impression made upon the Romans by the Jews in this very matter of Sabbath-keeping was widespread and deep. Jewish influence was felt and acknowledged almost from the time that Syria, of which Judea was but a petty division, became a Roman province, and a generation had not passed away before we find Horace making jocular allusion to the spread of the recognition of the Jewish Sabbath. In his 9th satire he describes himself as being buttonholed by a boor, and, seeing a friend pass by, as begging the latter to pretend business with him and so relieve him of his trouble. His friend mischievously excuses himself from talking about business. Today's the 30th Sabbath. Can you mean thus to insult the circumcised Jews? Persius, in his 5th satire, speaks of those who move their lips with silence, and with fear the Sabbath of the circumcised revere. Juvenal, in his 14th satire, describes how many Romans reverence the Sabbath, and their sons, bettering the example, turn Jews themselves. Others there are, whose sire the Sabbath heeds, and so they worship naught but clouds and sky. They deem swine's flesh, from which their father kept, no different from a man's. And soon indeed are circumcised, affecting to despise the laws of Rome, they study, keep and fear the Jewish law, whatever in mystic book Moses has handed down, to show the way to none but he who the same rites observes, and those athirst to lead unto the spring only if circumcised. Whereof the cause was he, their sire, to whom each seventh day was one of sloth, whereon he took in hand no part in life. Ovid, Tibullus, and others also speak of the Jewish Sabbath, not merely as universally known, but as largely observed amongst the Romans, so that it obtained almost a public recognition, whilst the success of Judaism in making proselytes, until Christianity came into rivalry with it, is known to every one. As to the general influence of Judaism in securing the recognition of the week with its seventh day of rest, the testimony of Josephus is emphatic. The multitude of mankind itself have had a great inclination of a long time to follow our religious observances, for there is not any city of the Grecians, nor any of the barbarians, nor any nation whatsoever, whither our custom of resting on the seventh day hath not come, and by which our fasts and lighting up lamps, and many of our prohibitions as to our food, are not observed. They also endeavor to imitate our mutual concord with one another, and the charitable distribution of our goods, and our diligence in our trades, and our fortitude in undergoing the distresses we are in, on account of our laws. And, what is here matter of the greatest admiration, our law hath no bait of pleasure to allure men to it, but it prevails by its own force, and as God himself pervades all the world, so hath our law passed through all the world also. 289:1, Philo, the Jew, bears equally distinct testimony to the fact that wheresoever the Jews were carried in their dispersion, their laws and religious customs, especially their observance of every seventh day, attracted attention, and even secured a certain amount of acceptance. The Jews, therefore, even when, as a nation, they were ruined and crushed, proved themselves possessed of such vital force, of such tenacity, as to impress their conquerors with interest in, and respect for, their sabbatic customs. Of their tenacity and force in general, of their power to influence the nations amongst whom they have been scattered, the history of the last 2,500 years is eloquent. It is not reasonable, nor scientific, to suppose that this nation, still since it returned from its captivity in Babylon, was wax before. But the third suggestion as to the origin of the week of 7 days, that it was derived from the influence of the planets, makes the matter clearer still. This suggestion has already been noticed in the chapter on Saturn and astrology. It is sufficient to say here that it presupposes a state of astronomical advancement not attained until long after the Sabbath was fully known. The Babylonians did observe the 7 planets, but there is no trace of their connection with the Babylonian week. But when the Greek astronomers had worked out that system of the planetary motions which we call after Ptolemy, and the planets had been fitted by the Alexandrian observers to the days of the Jewish week and the hours of the Egyptian day, then the Babylonian astrologers also adopted the mongrel combination. Thus indirectly Babylon received the free week from the Jews, and did not give it. The oldest use of the free and uniform week is found among the Jews, who had only a most imperfect knowledge of the planets. The identity of the number of the days in the week with that of the planets is purely accidental, and it is not permissible to assert that the former number is derived from the latter. 290:1, carried by the Jews into their dispersion, adopted by the Chaldean astrologers for use in their divinations, received by Christianity and Islam, this cycle, the free week of 7 days, so convenient and so useful for chronology, has now been adopted throughout the world. Its use can be traced back for about 3,000 years, and there is every reason to believe that it will last through the centuries to come, resisting the madness of useless novelty and the assaults of present and future iconoclasts. 290:2, the fourth account of the origin of the week is that given us in the Bible itself. In 6 days the Lord made heaven and earth, the sea, and all that in them is, and rested the 7th day, wherefore the Lord blessed the Sabbath day, and hallowed it. The institution of the Sabbath day is the crown of the work of creation, the key to its purpose. Other times and seasons are marked out by the revolutions and conjunctions of the heavenly bodies. This day is set apart directly by God himself, it is his express handiwork, the day which the Lord hath made. The great truth taught in the first chapter of Genesis is that God is the one reality. All that we can see above or around was made by him. He alone is God. And his creative work has a definite goal to which its several details all lead up, the creation of man, made in the image of God. As such, man has a higher calling than that of the beasts that perish. The chief object of their lives is to secure their food, their aspirations extend no further. But he is different, he has higher wants, nobler aspirations. How can they be met? The earth was created to form an abode suitable for man, the varied forms of organic life were brought into existence to prepare the way for and minister to him. For what was man himself made, and made in the image of God, but that he might know God and have communion with him? To this the Sabbath day gave the call, and for this it offered the opportunity. For what are men better than sheep or goats, that nourish a blind life within the brain, if, knowing God, they lift not hands of prayer? Footnotes 284:1. This is learnt from a single tablet of a Babylonian calendar, preserved in the British Museum, which unfortunately contains 1 month only. 285:1, Babel and Bible, Dr. Fried. Delitzsch, John's translation, pages 40, 41. 289:1, Flavius Josephus against Apion, Book 2. 40, 290:1, Schiaparelli, Astronomy in the Old Testament, page 135. 290:2, Ibid, page 133. Chapter 3. The month. The shortest natural division of time is the day. Next in length comes the month. As was pointed out in the chapter on the moon, the Hebrews used two expressions for month, chodesh, from a root meaning, to be new, and yerak, from the root meaning, to be pale. Chodesh is the word most commonly employed, and this, in itself, is sufficient to show that the Hebrew calendar month was a lunar one. But there are, besides, too many references to the actual new moons for there to be any doubt on the question. Every seventh day was commanded to be held as a Sabbath of rest, and on it were sacrificed 4 lambs, instead of the 2 offered up, the one at the morning and the other at the evening sacrifice of the 6 working days. But the new moons are also mentioned as holy days, and are coupled with the Sabbaths. The husband of the Shunammite asked her why she wished to go to Elisha, as, it is neither new moon, nor Sabbath. Isaiah, speaking in the name of the Lord, says, the new moons and Sabbaths, the calling of assemblies, I cannot away with. Your new moons and your appointed feasts my soul hateth, and again, from one new moon to another, and from one Sabbath to another, shall all flesh come to worship. Amos speaks of degenerate Israel, that they say, when will the new moon be gone, that we may sell corn? And the Sabbath, that we may set forth wheat? As late as apostolic times, St. Paul refers to the feasts of the new moons, saying, let no man therefore judge you in respect of the new moon. The ordinances respecting the observance of the new moons, the beginnings of months, were explicit. Trumpets were blown over the burnt offerings and over the sacrifices of the peace offerings, and the nature of these offerings is given in detail in the 28th chapter of the book of Numbers. The ordinances were reiterated and emphasized in the days of David, Solomon, Hezekiah, Ezekiel, Ezra and Nehemiah. Amongst the Jews of the present day the trumpets are not blown at new moons, extra prayers are read, but the burnt and peace offerings are of necessity omitted. Beside the new moons and the Sabbaths, the ancient Hebrews had 3 great festivals, all defined as to the time of their celebration by the natural months. The first was the feast of the Passover, which lasted a week, and began with the killing of a lamb, between the 2 evenings, on the 14th day of the month Abib, the first month of the year, that is to say, on the evening that the first moon of the year became full. This feast corresponded to our Easter. The second was that of Pentecost, and was bound to the feast of the Passover by being appointed to occur 7 weeks after the consecration of the harvest season by the offering of the sheaf on the 2nd day of the Passover. We still celebrate the feast of Pentecost, or Whitsunday, keeping it in remembrance of the birthday of the Christian Church. This feast lasted but a single day, and did not occur at either the new or the full of the moon, but nearly at first quarter. The third festival was threefold in its character. It began with special sacrifices besides those usually offered at the new moon. In the 7th month, on the 1st day of the month, ye shall have an holy convocation, ye shall do no servile work, it is a day of blowing of trumpets unto you. This then was especially dependent on the new moon, being on the 1st day of the month. On the 10th day of the month was the Day of Atonement, when the people should afflict their souls. On the 15th day of the month began the Feast of Tabernacles, which commenced on the night that the moon was full, and lasted for a week. We have no special religious seasons in the Christian Church to correspond with these. We thus see that with the Hebrews all the days of the new moons, and 2 days of full moon, in the 1st and in the 7th months, were days for which special ordinances were imposed. And there is no doubt that the beginnings of the new months were obtained by direct observation of the moon, when weather or other conditions permitted, not by any rule of thumb computation. The new moon observed was, necessarily, not the new moon as understood in the technical language of astronomy, i.e. the moment when the moon is in conjunction with the sun, having its dark side wholly turned towards the earth, and being in consequence completely invisible. The new moon, as mentioned in the scriptures, and as we ordinarily use the term, is not this conjunction, but the first visible crescent of the moon when it has drawn away from the sun sufficiently to be seen after sunset for a short time, in the twilight, before it sets, for the moon when very slender cannot be seen in daylight. It may, therefore, be first seen any time between about 18 hours and 40 hours after its conjunction with the sun. In other words, it may be first seen on one of 2 evenings. But for the ecclesiastical rites it was necessary that there should be an authoritative declaration as to the time of the commencement of the month, and, moreover, the great feasts were fixed for certain days in the month, and so were dependent on its beginning. During the period of the Jewish restoration, up to the destruction of Jerusalem by Titus, the Sanhedrim used to sit in the Hall of Polished Stones, to receive the testimony of credible witnesses that they had seen the new moon. If the new moon had appeared at the commencement of the 30th day, corresponding to our evening of the 29th, the Sanhedrim declared the previous month imperfect or consisting only of 29 days. If credible witnesses had not appeared to testify to the appearance of the new moon on the evening of the 29th, the next evening, i.e. that of the 30th, according to our mode of reckoning, was taken as the commencement of the new month, and the previous month was then declared to be full, or of 30 days. Early in the Christian era, it was enacted that no testimony should be received from unknown persons, because, says the Talmud, the Baithazites wished to impose on the Mishnaic rabbis, and hired 2 men to do so for 400 pieces of silver. It is clear, therefore, that about the time of the Christian era the beginnings of the months were determined astronomically from the actual observation of the new moons, and we may safely conclude that it was the same also from the earliest times. It was the actual new moon, not any theoretical or fictitious new moon, that regulated the great festivals, and, as we have seen, there was often some considerable uncertainty possible in the fixing of the dates. The witnesses might give conflicting testimony, and the authoritative date might be proved to be in fault. We have an instance of such conflicting authority in the different dating, on one occasion, of the Day of Atonement by the Rabbi Yehoshua, and Rabban Gamaliel, the president of the Sanhedrim, grandson of the Gamaliel at whose feet Paul sat. According to a statement in the Mishnah, dating from the 2nd century of our era, the appearance of the new moon at Jerusalem was signaled to Babylonia during the century preceding the destruction of the holy city by Titus, and perhaps from earlier times. The dispersion of the Jews had therefore presented them with an additional difficulty in fixing the beginning of their months. The problem is much more intricate today, seeing that the Jews are dispersed over the whole world, and the new moon, first visible on one evening at Jerusalem, might be seen the evening before, according to the reckoning of places west of Jerusalem, or might be invisible until the following evening, according to the reckoning of places east of it. We have the same problem to solve in finding the date of Easter Sunday. The prayer book rule for finding it runs thus: Easter Day is always the first Sunday after the full moon which happens upon, or next after, the 21st day of March, and if the full moon happens on a Sunday, Easter Day is the Sunday after. But the moon we choose for the ecclesiastical calendar is an imaginary body, which is so controlled by specially constructed tables as to be full on a day not differing by more than 2 or 3 days at most from the date on which the actual moon is full. This may seem, at first sight, a very clumsy arrangement, but it has the advantage of defining the date of Easter precisely, without introducing any question as to the special meridian where the moon might be supposed to be observed. Thus, in 1905, the moon was full at 4h56 m Greenwich Mean Time on the morning of March 21st. But Easter Day was not fixed for March 26th, the next Sunday following that full moon, but a month later, for April 23rd. For the calendar moon, the imaginary moon, was full on March 20th, and it may be added that the actual moon, though full on March 21st for European time, was full on March 20th for American time. There would have been an ambiguity, therefore, if the actual moon had been taken, according to the country in which it was observed, an ambiguity which is got rid of by adopting a technical or imaginary moon. The names given to the different months in Scripture have an interest of their own. For the most part the months are simply numbered. The month of the Passover is the first month, and the others follow, as the second, third, fourth, etc., throughout the year, examples of each occurring right up to the 12th month. There is no mention of a 13th month. But occasionally we find names as well as numbers given to the months. The first of these is Abib, meaning the month of green ears. This was the first month, the month of the Passover, and it received its name no doubt from the first green ears of barley offered before the Lord during the feast that followed the Passover. The second month was called Ziph, splendor, apparently referring to the splendor of the flowers in full springtime. It is mentioned together with 2 other names, Ethanim, the 7th month, and Bul, the 8th month, in the account of the building and dedication of Solomon's temple. The last 2 are certainly Phoenician names, having been found on Phoenician inscriptions. The first is possibly Phoenician also. Their occurrence in this special connection was no doubt a result of the very large part taken in the building of the temple and the construction of its furniture by the workmen of Hiram, king of Tyre. The Phoenician names of the months would naturally appear in the contracts and accounts for the work, side by side with the Hebrew equivalents, just as an English contractor today, in negotiating for a piece of work to be carried out in Russia, would probably take care to use the dating both of the Russian Old Style calendar, and of the English New Style. The word used for month in these cases is generally, not Chodesh, the month as beginning with the new moon, but Yerak, as if the chronicler did not wish them to be understood as having been determined by Jewish authorities or methods. In one case, however, Chodesh is used in connection with the month Ziph. The other instances of names for the months are Nisan, Sivan, Elul, Chislev, Tevet, Sebet, and Adar, derived from month names in use in Babylonia, and employed only in the books of Esther, Ezra, Nehemiah, and Zechariah, all avowedly post-exilic writers. The month word used in connection with them is Chodesh, since the Babylonian months were also lunar, except in the single case where Ezra used a month name, terming it Yerak. The other post-exilic writers or editors of the books of Holy Scripture would seem to have been at some pains to omit all Babylonian month names. These Babylonian month names continue to be used in the Jewish calendar of today. In 4 places in Scripture mention is made of a month of days, the word for month being in 2 cases Chodesh, and in 2, Yerak. Jacob, when he came to Padan Aram, abode with Laban for the space of a month, before his crafty uncle broached the subject of his wages. This may either merely mean full 30 days, or the term Chodesh may possibly have a special appropriateness, as Laban may have dated Jacob's service so as to commence from the second new moon after his arrival. Again, when the people lusted for flesh in the wilderness, saying, Who shall give us flesh to eat? The Lord promised to send them flesh, and ye shall eat. Ye shall not eat 1 day, nor 2 days, nor 5 days, neither 10 days, nor 20 days, but even a whole month. And there went forth a wind from the Lord, and brought quails from the sea. He rained flesh also upon them as dust, and feathered fowls like as the sand of the sea. The whole month, in this case was evidently a full period of 30 days, irrespective of the particular phase of the moon when it began and ended. Amongst the Babylonians the sign for the word month was XXX, expressing the usual number of days that it contained, and without doubt amongst the Hebrews that was the number of days originally assigned to the month, except when the interval between two actually observed new moons was found to be 29. In later times it was learned that the length for the lunation lay between 29 and 30 days, and that these lengths for the month must be alternate as a general rule. But in early times, if a long spell of bad weather prevented direct observation of the new moon, we cannot suppose that anything less than 30 days would be assigned to each month. Such a long spell of bad observing weather did certainly occur on one occasion in the very early days of astronomy, and we accordingly find that such was the number of days allotted to several consecutive months, though the historian was evidently in the habit of observing the new moon, for Chodesh is the word used to express these months of 30 days. We are told that, in the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. And later that, after the end of the 150 days the waters were abated. And the ark rested in the 7th month, on the 17th day of the month, upon the mountains of Ararat. The 5 months during which the waters prevailed upon the earth were, therefore, reckoned as of 30 days each. If all the new moons, or even that of the 7th month, had been actually observed, this event would have been ascribed to the 19th day of the month, since 150 days is 5 months and 2 days, but in the absence of such observations a sort of dead reckoning was applied, which would of course be corrected directly the return of clear weather gave an opportunity for observing the new moon once again. A similar practice was followed at a much later date in Babylon, where astronomy is supposed to have been highly developed from remote antiquity. Thus an inscription recently published by Dr. L. W. King records that, on the 26th day of the month Sivan, in the 7th year, the day was turned into night and fire in the midst of heaven. This has been identified by Mr. P. H. Cowell, F.R.S., Chief Assistant at the Royal Observatory, Greenwich, as the eclipse of the sun that was total at Babylon on July 31, B.C. 1063. The Babylonians, when bad weather obliged them to resort to dead reckoning, were, therefore, still reckoning the month as precisely 30 days so late as the times of Samuel and Saul, and in this particular instance were 2, if not 3, days out in their count. Had the new moon of Sivan been observed, or correctly calculated, the eclipse must have been reckoned as falling on the 28th or 29th day of the month. The Athenians in the days of Solon, 500 years later than this, adopted months alternately 29 and 30 days in length, which gives a result very nearly correct. The Jews after the dispersion adopted the system of thus alternating the lengths of their months, and with some slight modifications it holds good to the present day. As will be shown in the following chapter, the ordinary years are of 12 months, but 7 years in every 19 are embolismic, having an extra month. The names employed are those learned during the Babylonian captivity, and the year begins with the month Tishri, corresponding to September-October of our calendar. The lengths of most of the months are fixed as given in the following table, but any adjustment necessary can be effected either by adding 1 day to Heshvan, which has usually 29 days, or taking away 1 day from Kislev, which has usually 30, ordinary year embolismic year days Tishri 30 Heshvan 29 plus Kislev 30 Tevath 29 Shebat 30 Adar 29 V Adar 29 Nisan 30 Yair 29 Sivan 30 Tammuz 29 Ab 30 Elul 29 The Jewish month, therefore, continues to be essentially a true lunar one, though the exact definition of each month is, to some extent, conventional, and the words of the son of Sirach still apply to the Hebrew calendar. The moon also is in all things for her season, for a declaration of times, and a sign of the world. From the moon is the sign of the feast day, a light that wanneth when she is come to the full. For so God appointed the moon for seasons. Chapter 4 The year. The third great natural division of time is the year, and, like the day and the month, it is defined by the relative apparent movements of the heavenly bodies. As the Rabbi Ibn Ezra pointed out, Shana, the ordinary Hebrew word used for year, expresses the idea of annus or annulus, a closed ring, and therefore implies that the year is a complete solar one. A year, that is purely lunar, consists of 12 lunations, amounting to 354 days. Such is the year that the Mohammedans use, and since it falls short of a solar year of 365 days by 10 or 11 days, its beginning moves backwards rather rapidly through the seasons. The Jews used actual lunations for their months, but their year was one depending on the position of the sun, and their calendar was therefore a lunisolar one. But lunations cannot be made to fit in exactly into a solar year. 12 lunations are some 11 days short of 1 year, 37 lunations are 2 or 3 days too long for 3 years, but an approximation can be made by giving an extra month to every third year, or more nearly still by taking 7 years in every 19 as years of 13 months each. This 13th month is called an intercalary month, and in the present Jewish calendar it is the month Adar which is reduplicated under the name of Adar. But, though from the necessity of the case, this intercalation, from time to time, of a 13th month must have been made regularly from the first institution of the Feast of Unleavened Bread, we find no allusion, direct or indirect, in the Hebrew Scriptures to any such custom. Amongst the Babylonians a year and a month were termed full when they contained 13 months and 30 days respectively, and normal or incomplete when they contained but 12 months or 29 days. The succession of full and normal years recurred in the same order, at intervals of 19 years. For 19 years contained 6,939 days 14, 1/2 hours, and 235 months, 6,939 days 16, 1/2 hours, the two therefore differing only by about a couple of hours. The discovery of this cycle is attributed to Meton, about 433 B.C., and it is therefore known as the Metonic cycle. It supplies the golden numbers of the introduction to the Book of Common Prayer. There are two kinds of solar years, with which we may have to do in a lunisolar calendar, the tropical or equinoctial year, and the sidereal year. The tropical year is the interval from one season till the return of that season again, spring to spring, summer to summer, autumn to autumn, or winter to winter. It is defined as the time included between two successive passages of the sun through the vernal equinox, hence it is also called the equinoctial year. Its length is found to be 365 days, 5 hours, 49 minutes, and some ancient astronomers derived its length as closely as 365 days, 6 hours, by observing the dates when the sun set at exactly the opposite part of the horizon to that where it rose. The sidereal year is the time occupied by the sun in apparently completing the circuit of the heavens from a given star to the same star again. The length of the sidereal year is 365 days, 6 hours, 9 minutes. In some cases the ancients took the sidereal year from the heliacal risings or settings of stars, that is from the interval between the time when a bright star was first seen in the morning just before the sun rose, until it was first so seen again, or last seen just after the sun set in the evening, until it was last so seen again. But to connect the spring new moon with the day when the sun has returned to the equinox is a more difficult and complicated matter. The early Hebrews would seem to have solved the problem practically, by simply watching the progress of the growing grain. If at one new moon in springtime it appeared clear that some of the barley would be ready in a fortnight for the offering of the green ears at the Feast of Unleavened Bread, then that was taken as beginning the new year. If it appeared doubtful if it would be ready, or certain that it would not be, then the next new moon was waited for. This method was sufficient in primitive times, and so long as the nation of Israel remained in its own land. In the long run, it gave an accurate value for the mean tropical year, and avoided all the astronomical difficulties of the question. It shows the early Hebrews as practical men, for the solution adopted was easy, simple and efficient. This practical method of determining the beginning of the year amongst the early Hebrews, does not appear to have been the one in use amongst the Babylonians either early or late in their history. The early Babylonians used a sidereal year, as will be shown shortly. The later Babylonians used a tropical year dependent on the actual observation of the spring equinox. To those who have no clocks, no telescopes, no sundials, no instruments of any kind, there are two natural epochs at which the day might begin, at sunrise, the beginning of daylight, and at sunset, the beginning of darkness. Similarly, to all nations which use the tropical year, whether their calendar is dependent on the sun alone, or on both sun and moon, there are two natural epochs at which the year may begin, at the spring equinox, the beginning of the bright half of the year, when the sun is high in the heavens, and all nature is reviving under its heat and light, and at the autumn equinox, the beginning of the dark half of the year, when the sun is low in the heavens, and all nature seems dying. As a nation becomes more highly equipped, both in the means of observing, and in knowledge, it may not retain either of these epochs as the actual beginning of its year, but the determination of the year still rests directly or indirectly upon the observation of the equinoxes. At the exodus from Egypt, in the month Abib, the children of Israel were commanded in these words, "This month shall be unto you the beginning of months, it shall be the first month of the year to you." This command may have abolished and reversed the previously existing calendar, or it may have related solely to the ecclesiastical calendar, and the civil calendar may have been still retained with a different epoch of commencement. An inquiry into the question as to whether there is evidence in Scripture of the use of a double calendar, shows that in every case that the Passover is mentioned it is as being kept in the first month, except when Hezekiah availed himself of the regulation which permitted its being kept in the second month. Since the Passover was a spring feast, this links the beginning of the year to the springtime. Similarly, the Feast of Tabernacles, which is an autumn festival, is always mentioned as being held in the seventh month. These feasts would naturally be referred to the ecclesiastical calendar. But the slight evidences given in the civil history point the same way. Thus some men joined David at Ziklag during the time of his persecution by Saul, in the first month. This was springtime, for it is added that Jordan had overflowed all its banks. Similarly, the ninth month fell in the winter, for it was as he sat in the winter house in the ninth month, and there was a fire on the hearth burning before him, that King Jehoiakim took the prophecy of Jeremiah and cut it with the penknife, and cast it into the fire that was on the hearth. The same ninth month is also mentioned in the book of Ezra as a winter month, a time of great rain. The same result is given by the instances in which a Babylonian month name is interpreted by its corresponding Jewish month number. In each case the Jewish year is reckoned as beginning with Nisan, the month of the spring equinox. In one case, however, two Babylonian month names do present a difficulty. In the book of Nehemiah, in the first chapter, the writer says, "It came to pass in the month Chislew, in the 20th year, as I was in Shushan the palace, that Hanani, one of my brethren, came, and told him concerning the sad state of Jerusalem." In consequence of this he subsequently approached the king on the subject, in the month Nisan, in the 20th year of Artaxerxes the king. If the 20th year of King Artaxerxes began in the spring, Nisan, which is a spring month, could not follow Chislew, which is a month of late autumn. But Artaxerxes may have dated his accession, and therefore his regnal years, from some month between Nisan and Chislew, or the civil year may have been reckoned at the court of Shushan as beginning with Tishri. It may be noted that Nehemiah does not define either of these months in terms of the Jewish. Elsewhere, when referring to the Jewish Feast of Tabernacles, he attributes it to the seventh month, in accord with its place in the Mosaic calendar. An alteration of the beginning of the year from the spring to the autumn was brought about amongst the Jews at a later date, and was systematized in the religious calendar by the rabbis of about the 4th century A.D. Tishri begins the Jewish year at the present day, the first day of Tishri being taken as the anniversary of the creation of the world. The Mishnah, the law of the lip, was first committed to writing in 191 A.D., and the compilation of the Babylonian Talmud, based on the Mishnah, was completed about 500 A.D. In its commentary on the first chapter of Genesis, there is an allusion to the year as beginning in spring, for it says that, "A king crowned on the 29th of Adar is considered as having completed the first year of his reign on the 1st of Nisan, i.e. the next day." Hence follows, observe someone, that the 1st of Nisan is the New Year's Day of Kings, and that if one had reigned only one day in a year, it is considered as a whole year. 311:1, it is not indicated whether this rule held good for the kings of Persia, as well as for those of Israel. If so, and this tradition be correct, then we cannot explain Nehemiah's reckoning by supposing that he was counting from the month of the accession of Artaxerxes, and must assume that a civil or court year beginning with Tishri, i.e. in the autumn, was the one in question. A further, but, as it would seem, quite an imaginary difficulty, has been raised because the Feast of Ingathering, or Tabernacles, though held in the 7th month, is twice spoken of as being, in the end of the year, or, as it is rendered in the margin in one case, in the revolution of the year. This latter expression occurs again in 2 Chron. 24:23, when it is said that, at the end of the year, the host of Syria came up, but in this case it probably means early spring, for it is only of late centuries that war has been waged in the winter months. Down to the Middle Ages, the armies always went into winter quarters, and in the spring the kings led them out again to battle. One Hebrew expression used in Scripture means the return of the year, as applied to the close of one and the opening of another year. This is the expression employed in the 2nd book of Samuel, and of the 1st book of Chronicles, where it is said, after the year was expired, at the time when kings go forth to battle, implying that in the time of David the year began in the spring. The same expression, no doubt in reference to the same time of the year, is also used in connection with the warlike expeditions of Ben-Hadad, king of Syria, and of Nebuchadnezzar, king of Babylon. It is admitted that the Feast of Tabernacles was held in the autumn, and in the 7th month. The difficulty lies in the question of how it could be said to be, in the end of the year, at the year's end, although it is clear from the cases just cited that these and similar expressions are merely of a general character, as we ourselves might say, when the year came round, and do not indicate any rigid connection with a specific date of the calendar. We ourselves use several years and calendars, without any confusion. The civil year begins, at midnight, on January 1st, the financial year on April 1st, the ecclesiastical year with Advent, about December 1st, the scholastic year about the middle of September, and so on. As the word year expresses with ourselves many different usages, there is no reason to attribute to the Jews the extreme pedantry of invariably using nothing but precise definitions drawn from their ecclesiastical calendar. The services of the tabernacle and the temple were, with the exception of the slaying of the paschal lambs, all comprised within the hours of daylight. There was no offering before the morning sacrifice, none after the evening sacrifice. So, too, the Mosaic law directed all the great feasts to be held in the summer half of the year, the light half, none in the winter. The paschal full moon was just after the spring equinox, the harvest moon of the Feast of Tabernacles as near as possible to the autumn equinox. Until the introduction, after the captivity, of the Feast of Purim in the 12th month, the month Adar, the ecclesiastical year might be said to end with those 7 days of joyous camping out in the booths built of the green boughs, just as all the great days of the Christian year lie between Advent and the octave of Pentecost, whilst the Sundays after Trinity stretch their length through 6 whole months. There is, therefore, no contradiction between the command in Exodus 12 to make Abib, the month of the Passover, the 1st month, and the references elsewhere in Exodus to the Feast of Ingathering as being in the end of the year. It was at the end of the agricultural year, it was also at the end of the period of feasts. So, if a workman is engaged for a day's work, he comes in the morning, and goes home in the evening, and expects to be paid as he leaves, no one would ask him to complete the 24 hours before payment and dismissal. It is the end of his day, though, like the men in the parable of the laborers in the vineyard, he has only worked 12 hours out of the 24. In the same way the Feast of Tabernacles, though in the 7th month, was in the end of the year, both from the point of view of the farmer and of the ordinances of the sacred festivals. The method employed in very early times in Assyria and Babylonia for determining the 1st month of the year was a simple and effective one, the principle of which may be explained thus: if we watch for the appearance of the new moon in springtime, and, as we see it setting in the west, notice some bright star near it, then 12 months later we should see the two together again, but with this difference, that the moon and star would be seen together, not on the 1st, but on the 2nd evening of the month. For since 12 lunar months fall short of a solar year by 11 days, the moon on the 1st evening would be about 11 degrees short of her former position. But as she moves about 13 degrees in 24 hours, the next evening she would practically be back in her old place. In the second year, therefore, moon and star would set together on the second evening of the first month, and in like manner they would set together on the third evening in the third year, and, roughly speaking, on the fourth evening of the fourth year. But this last conjunction would mean that they would also set together on the first evening of the next month, which would thus be indicated as the true first month of the year. Thus when moon and star set together on the third evening of a month, 13 months later they would set together on the first evening of a month. Thus the setting together of moon and star would not only mark which was to be first month of the year, but if they set together on the first evening it would show that the year then beginning was to be an ordinary one of 12 months, if on the third evening, that the year ought to be a full one of 13 months. This was precisely the method followed by the Acadians some 4,000 years ago. For Professor Sayce and Mr. Bosanquet translate an old tablet in Akkadian as follows: when on the first day of the month Nisan the star of stars, or Dilgan, and the moon are parallel, that year is normal. When on the third day of the month Nisan the star of stars and the moon are parallel, that year is full. 315:1, the star of stars of this inscription is no doubt the bright star Capella, and the year thus determined by the setting together of the moon and Capella would begin on the average with the spring equinox about 2000 B.C. When Capella thus marked the first month of the year, the twin stars, Castor and Pollux, marked the second month of the year in just the same way. A reminiscence of this circumstance is found in the signs for the first 2 months, that for the first month being a crescent moon lying on its back, that for the second month a pair of stars. The significance of the crescent being shown as lying on its back is seen at once when it is remembered that the new moon is differently inclined to the horizon according to the time of the year when it is seen. It is most nearly upright at the time of the autumn equinox, it is most nearly horizontal, lying on its back, at the spring equinox. It is clear from this symbol, therefore, that the Babylonians began their year in the spring. Position of the new moon at the equinoxes. Position of the new moon at the equinoxes. To list this method, by which the new moon was used as a kind of pointer for determining the return of the sun to the neighborhood of a particular star at the end of a solar year, is quite unlike anything that commentators on the astronomical methods of the ancients have supposed them to have used. But we know from the ancient inscription already quoted that it was actually used, it was eminently simple, it was bound to have suggested itself wherever a lunisolar year, starting from the observed new moon, was used. Further, it required no instruments or star maps, it did not even require a knowledge of the constellations, only of 1 or 2 conspicuous stars. Though rough, it was perfectly efficient, and would give the mean length of the year with all the accuracy that was then required. Boundary stone in the Louvre. Boundary stone in the Louvre, approximate date, B.C. 1200. From a photograph by Messrs. W. A. Mansell. To list, but it had one drawback, which the ancients could not have been expected to foresee. The effect of precession, alluded to in the chapter on The Origin of the Constellations, page 158, would be to throw the beginning of the year, as thus determined, gradually later and later in the seasons, roughly speaking, by a day in every 70 years, and the time came, no doubt, when it was noticed that the terrestrial seasons no longer bore their traditional relation to the year. This probably happened at some time in the 7th or 8th centuries before our era, and was connected with the astronomical revolution that has been alluded to before, when the ecliptic was divided into 12 equal divisions, not associated with the actual stars, the signs were substituted for the constellations of the zodiac, and the ram was taken as the leader instead of the bull. The equinox was then determined by direct measurement of the length of the day and night, for a tablet of about this period records, on the 6th day of the month Nisan the day and night were equal. The day was 6 double hours, Casbu, and the night was 6 double hours. So long as Capella was used as the indicator star, so long the year must have begun with the sun in Taurus, the bull, but when the readjustment was made, and the solar tropical year connected with the equinox was substituted for the sidereal year connected with the return of the sun to a particular star, it would be seen that the association of the beginning of the year with the sun's presence in any given constellation could no longer be kept up. The necessity for an artificial division of the zodiac would be felt, and that artificial division clearly was not made until the sun at the spring equinox was unmistakably in Aries, the ram, or about 700 BC. The eclipse of 1063 BC incidentally proves that the old method of fixing Nisan by the conjunction of the moon and Capella was then still in use, for the eclipse took place on July 31st, which is called in the record the 26th of Sivan. Sivan being the third month, its 26th day could not have fallen so late, if the year had begun with the equinox, but it would have so fallen if the Capella method were still in vogue. There is a set of symbols repeated over and over again on Babylonian monuments, and always given a position of eminence. It is the so-called triad of stars, a crescent lying on its back and two stars near it. They are seen very distinctly at the top of the photograph of the boundary stone from the Louvre, given on page 318, and also immediately above the head of the sun god in the photograph of the tablet from Sippar, on page 322. Their significance is now clear. For 1,000 years before the Christian era, the two twin stars, Castor and Pollux, served as indicators of the first new moon of the year, just as Capella did 2,000 years later. The triad of stars, then, is simply a picture of what men saw, year after year, in the sunset sky at the beginning of the first month, 6,000 years ago. It is the earliest record of an astronomical observation that has come down to us. Worship of the sun god at Sippara. Worship of the sun god at Sippra. To list how simple and easy the observation was, and how distinctly the year was marked off by it. The month was marked off by the first sight of the new thin crescent in the evening sky. The day was marked off by the return of darkness, the evening hour in which, month by month, the new moon was first observed, so that, the evening and the morning were the first day. The year was marked off by the new moon being seen in the evening with a bright pair of stars, the stars we still know as the twins, and the length of the year was shown by the evening of the month, when moon and stars came together. If on the first evening, it was a year of 12 months, if on the third, one of 13. There was a time when these three observations constituted the whole of primitive astronomy. In later days the original meaning of the triad of stars would seem to have been forgotten, and they were taken as representing Sin, Samus, and Istar, the moon, the sun and the planet Venus. Yet now and again a hint of the part they once played in determining the length of the year is preserved. Thus, on the tablet now in the British Museum, and shown on page 322, sculptured with a scene representing the worship of the sun god in the temple of Sippar, these three symbols are shown with the explanatory inscription, the moon god, the sun god, and Istar, dwellers in the abyss, announce to the years what they are to expect, possibly an astrological formula, but it may well mean, announce whether the years should expect 12 or 13 months. As already pointed out, this method had one drawback: it gave a sidereal year, not a tropical year, and this inconvenience must have been discovered, and Capella substituted for the twin stars, long before the giving of the law to Israel. The method employed by the priests of watching the progress of the ripening of the barley overcame this difficulty, and gave a year to Israel which, on the average, was a correct tropical one. There is a detail in the history of the flood in Gen 7 and 8, which has been taken by some as meant to indicate the length of the tropical year. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. And it came to pass in the 601st year. In the second month, on the 27th day of the month, was the earth dried. The interval from the commencement of the deluge to its close was therefore 12 lunar months and 10 days, i.e. 364 or 365 days. The beginning of the rain would, no doubt, be sharply marked, the end of the drying would be gradual, and hence the selection of a day exactly, so far as we can tell, a full tropical year from the beginning of the flood would seem to be intentional. A complete year had been consumed by the judgment. No such total interruption of the kindly succession of the seasons shall ever occur again, while the earth remaineth, seed time and harvest, and cold and heat, and summer and winter, and day and night shall not cease. The rain is no longer for judgment, but for blessing, thou visitest the earth, and waterest it, thou greatly enrichest it, the river of God is full of water, thou providest them corn, when thou hast so prepared the earth. Thou waterest her furrows abundantly, thou settlest the ridges thereof, thou makest it soft with showers, thou blessest the springing thereof. Thou crownest the year with thy goodness. Footnotes: 311:1, p.I. Herzhan, Genesis with a Talmudical commentary, page 30. 315:1, Monthly Notices of the Royal Astronomical Society, Volume 39. Page 455. Chapter V. The Sabbatic Year and the Jubilee. The principle of the week with its Sabbath of rest was carried partially into the month, and completely into the year. The seventh month of the year was marked out preeminently by the threefold character of its services, though every seventh month was not distinguished. But the weekly Sabbath was expressed not only in days but in years, and was one both of rest and of release. The Sabbath of years was first enjoined from Mount Sinai, in the third month after the departure from Egypt, certainly within a day or so, if not on the actual day, of the second great feast of the year, variously known to the Hebrews as the Feast of Firstfruits, or the Feast of Weeks, and to us as Pentecost, that is Whitsuntide. It is most shortly given in Exodus 21. 2, and 23. 10, 11, If thou buy an Hebrew servant, 6 years he shall serve, and in the 7th he shall go out free for nothing. 6 years thou shalt sow thy land, and shalt gather in the fruits thereof, but the 7th year thou shalt let it rest and lie still, that the poor of thy people may eat, and what they leave the beasts of the field shall eat. In like manner thou shalt deal with thy vineyard, and with thy oliveyard. These laws are given at greater length and with fuller explanation in the 25th chapter of the book of Leviticus. In addition there is given a promise of blessing for the fulfillment of the laws, and, in the 26th chapter, a sign to follow on their breach. If ye shall say, What shall we eat the 7th year? Behold, we shall not sow, nor gather in our increase, then I will command my blessing upon you in the 6th year, and it shall bring forth fruit for 3 years. And ye shall sow the 8th year, and eat yet of old fruit until the 9th year, until her fruits come, and ye shall eat of the old store. Ye shall keep my Sabbaths. And if ye walk contrary unto me, I will scatter you among the heathen, and will draw out a sword after you, and your land shall be desolate and your cities waste. Then shall the land enjoy her Sabbaths, as long as it lieth desolate, and ye be in your enemy's land, even then shall the land rest, and enjoy her Sabbaths. As long as it lieth desolate it shall rest, because it did not rest in your Sabbaths, when ye dwelt upon it. In the 15th chapter of the book of Deuteronomy this Sabbatic year is called a year of release. The specific injunctions here relate to loans made to a Hebrew and to a foreigner, and to the taking of a Hebrew into bondage. The laws as to loans had direct reference to the Sabbath of the land, for since only Hebrews might possess the Holy Land, interest on a debt might not be exacted from a Hebrew in the Sabbatic year, as the land did not then yield him wherewith he might pay. But loans to foreigners would be necessarily for commercial, not agricultural, purposes, and since commerce was not interdicted in the Sabbatic year, interest on loans to foreigners might be exacted. Warning was given that the loans to a poor Hebrew should not be withheld because the Sabbatic year was close at hand. The rules with respect to the Hebrew sold for debt into bondage are the same as those given in the book of the Exodus. In Deuteronomy it was also enjoined that, at the end of every 7 years, in the solemnity of the year of release, in the Feast of Tabernacles, that is, in the feast of the 7th month, when all Israel is come to appear before the Lord thy God in the place which he shall choose, thou shalt read this law before all Israel in their hearing. We find no more mention of the Sabbatic year until the reign of Zedekiah, the last king of Judah. He had made a covenant with all the people which were at Jerusalem, to proclaim liberty unto them, that every Hebrew bondservant should go free, but the princes and all the people caused their Hebrew bondservants to return and be in subjection to them. Then Jeremiah the prophet was sent to remind them of the covenant made with their fathers when they were brought out from the land of Egypt, from the house of bondmen, and in the 2nd book of Chronicles it is said that the sign of the breaking of this covenant, already quoted from the book of Leviticus, was being accomplished. The captivity was, to fulfill the word of the Lord by the mouth of Jeremiah, until the land had enjoyed her Sabbaths, for as long as she lay desolate she kept Sabbath, to fulfill 60 years. After the exile, we find one reference to the Sabbatic year in the covenant sealed by the princes, Levites, and priests and people, in the book of Nehemiah, that we would leave the 7th year, and the exaction of every debt. Just as the Feast of Weeks was bound to the feast of the Passover by numbering 7 Sabbaths from the day of the wave offering, even unto the morrow after the 7th Sabbath shall ye number 50 days, so the year of Jubilee was bound to the Sabbatic year. Thou shalt number 7 Sabbaths of years unto thee, 7 times 7 years, and the space of the 7 Sabbaths of years shall be unto thee 49 years. Then shalt thou cause the trumpet of the jubile to sound on the 10th day of the 7th month, in the day of atonement shall ye make the trumpet sound throughout all your land. And ye shall hallow the 50th year, and proclaim liberty throughout all the land unto all the inhabitants thereof, it shall be a jubile unto you, and ye shall return every man unto his possession, and ye shall return every man unto his family. In this year of Jubilee all land, and village houses, and the houses of the Levites were to revert to their original owners. These, in other words, could be leased only, and not bought outright, the price of the lease depending upon the number of years until the next Jubilee. A foreigner might not buy a Hebrew outright as a bond slave, he could but contract with him as a servant hired for a term. This contract might be abolished by the payment of a sum dependent on the number of years until the next year of Jubilee, and in any case the Hebrew servant and his family must go out free at the year of Jubilee. In the last chapter of the book of Numbers we get a reference again to the year of Jubilee, and indirect allusions to it are made by Isaiah, in the acceptable year of the Lord, when liberty should be proclaimed, and in the year of the redeemed. In his prophecy of the restoration of Israel, Ezekiel definitely refers to the year of liberty, when the inheritance that has been granted to a servant shall return again to the prince. The interpretation of the Sabbatic year and the year of Jubilee has greatly exercised commentators. At what season did the Sabbatic year begin? Was it coterminous with the ecclesiastical year, or did it differ from it by 6 months? Was the year of Jubilee held once in every 49 years or once in every 50? Did it begin at the same season as the Sabbatic year? Did it interrupt the reckoning of the Sabbatic year, so that a new cycle commenced immediately after the year of Jubilee, or was the Sabbatic year every 7th, irrespective of the year of Jubilee? Did the year of Jubilee always follow immediately on a Sabbatic year, or did this only happen occasionally? The problem will be much simpler if it is borne in mind that the law, as originally proclaimed, was eminently practical and for practical men. The period of pedantry, of hair-splitting, of slavery to mere technicalities, came very late in Jewish history. It is clear from what has been already said in the chapter on the year, that the only calendar year in the Old Testament was the sacred one, beginning with the month Abib or Nisan, in the spring. At the same time the Jews, like ourselves, would occasionally refer vaguely to the beginning, or the end, or the course of the year, without meaning to set up any hard and fast connection with the authorized calendar. Now it is perfectly clear that the Sabbatic year cannot have begun with the first day of the month Abib, because the first fruits were offered on the 15th of that month. That being so, the plowing and the sowing must have taken place very considerably earlier. It is not possible to suppose that the Hebrew farmer would plow and sow his land in the last months of the previous year, knowing that he could not reap during the Sabbatic year. Similarly, it seems hardly likely that it was considered as beginning with the first of Tishri, inasmuch as the harvest festival, the feast of the ingathering, or tabernacles, took place in the middle of that month. The plain and practical explanation is that, after the feast of tabernacles of the 6th year, the farmer would not again plow, sow, or reap his land until after the Feast of Tabernacles in the Sabbatic year. The Sabbatic year, in other words, was a simple agricultural year, and it did not correspond exactly with the ecclesiastical or with any calendar year. For practical purposes the Sabbatic year therefore ended with the close of the Feast of Tabernacles, when the law was read before the whole people according to the command of Moses, and it practically began a year earlier. The year of Jubilee appears in the directions of Leviticus 25. To have been most distinctly linked to the Sabbatic year. The space of the 7 Sabbaths of years shall be unto thee 49 years. And ye shall hallow the 50th year, and proclaim liberty throughout all the land unto all the inhabitants thereof, it shall be a jubile unto you. It would seem, therefore, that just as the week of days ran on continuously, uninterrupted by any feasts or fasts, so the week of years ran on continuously. And as the feast of Pentecost was the 49th day from the offering of the firstfruits on the morrow of the Passover, so the Jubilee was the 49th year from the morrow of a sabbatic year, it followed immediately after a sabbatic year. The Jubilee was thus the 49th year from the previous Jubilee, it was the 50th from the particular sabbatic year from which the original reckoning was made. Actually the year of Jubilee began before the sabbatic year was completed, because the trumpet of the Jubilee was to be blown upon the Day of Atonement, the 10th day of the 7th month, that is to say, whilst the sabbatic year was yet in progress. Indeed, literally speaking, this trumpet, loud of sound, blown on the 10th day of the 7th month, was the Jubilee, that is to say, the sound of rejoicing, the joyful sound. A difficulty comes in here. The Israelites were commanded, Ye shall not sow, neither reap that which groweth of itself in it, nor gather the grapes in it of thy vine undressed. For it is the jubile, it shall be holy unto you, ye shall eat the increase thereof out of the field. This would appear to mean that the Jubilee extended over a whole year following a sabbatic year, so that the land lay fallow for 2 consecutive years. But this seems negatived by 2 considerations. It is expressly laid down in the same chapter, Leviticus 25:22, that the Israelites were to sow in the 8th year, that is to say, in the year after a sabbatic year, and the year of Jubilee would be always a year of this character. Further, if the next sabbatic year was the 7th after the one preceding the Jubilee, then the land would be tilled for only 5 consecutive years, not for 6, though this is expressly commanded in Leviticus 25:3. If, on the contrary, it was tilled for 6 years, then the run of the sabbatic years would be interrupted. The explanation of this difficulty may possibly be found in the fact that that which distinguished the year of Jubilee was something which did not run through the whole circuit of the seasons. The land in that year was to return to its original owners. The freehold of the land was never sold, the land was inalienable, and in the year of Jubilee it reverted. In the year of this Jubilee ye shall return every man unto his possession. It is quite clear that it could not have been left to the caprice of the owners of property as to when this transfer took place, or as to when such Hebrews as had fallen through poverty into slavery should be liberated. If the time were made optional, grasping men would put it off till the end of the year, and sooner or later that would be the general rule. There can be no doubt that the blowing of the trumpet on the 10th day of the 7th month was the proclamation of liberty throughout all the land and to all the inhabitants thereof, and that the transfer of the land must have taken place at the same time. The slave would return to the possession of his ancestors in time to keep, as a freeman, the Feast of Tabernacles on his own land. The 4 days between the Great Day of Atonement and the Feast of Tabernacles were sufficient for this change to be carried out. The term Year of Jubilee is therefore not to be taken as signifying that the events of the Jubilee were spread over 12 months, but simply, that it was the year in which the restoration of the Jubilee was accomplished. We speak of the king's coronation year, though his coronation took place on but a single day, and the meaning that we should attach to the phrase would depend upon the particular sense in which we were using the word year. Whilst, therefore, the Jubilee itself was strictly defined by the blowing of trumpets on the 10th day of the 7th month, it would be perfectly correct to give the title, Year of Jubilee, to any year, no matter in what season it commenced, that contained the day of that proclamation of liberty. It is also correct to say that it was the 50th year because it was placed at the very end of the 49th year. The difficulty still remains as to the meaning of the prohibition to sow or reap in the year of Jubilee. The command certainly reads as if the land was to lie fallow for 2 consecutive years, but it would seem an impracticable arrangement that the poor man returning to his inheritance should be forbidden to plough or sow until more than a 12-month had elapsed, and hence that he should be forbidden to reap until nearly 2 full years had run their course. It also, as already stated, seems directly contrary to the command to sow in the 8th year, which would also be the 50th. It may therefore be meant simply to emphasize the prohibition to sow and reap in the sabbatic year immediately preceding the Jubilee. The temptation would be great to a grasping man to get the most he could out of the land before parting with it forever. In spite of the strong array of commentators who claim that the Jubilees were to be held every 50 years as we moderns should compute it, there can be no doubt but that they followed each other at the same interval as every seventh sabbatic year, in other words, that they were held every 49 years. This is confirmed by an astronomical consideration. 49 years make a convenient lunisolar cycle, reconciling the lunar month and the tropical solar year. Though not so good as the Metonic cycle of 19 years, it is quite a practical one, as the following table will show: 3 years equals 1095, 73 days, 37 months equals 1092, 63 days, 8 equals 29, 21, 94, 99 equals 29, 23, 53, 11 equals 40, 17, 66, 136 equals 40, 16, 16, 19 equals 69, 39, 60, 235 equals 69, 39, 69, 49 equals 17896, 87, 606 equals 17895, 54, 60 equals 21914, 53, 742 equals 21911, 70. The cycle of 49 years would therefore be amply good enough to guide the priestly authorities in drawing up their calendar in cases where there was some ambiguity due to the interruption of observations of the moon, and this was all that could be needed so long as the nation of Israel remained in its own land. The cycle of 8 years is added above, since it has been stated that the Jews of Alexandria adopted this at one time from the Greeks. This was not so good as the cycle of 11 years would have been, and not to be compared with the combination of the two cycles in that of 19 years ascribed to Meton. The latter cycle was adopted by the Babylonian Jews, and forms the basis of the Jewish calendar in use today. Chapter 6 The cycles of Daniel. The cycle of 49 years, marked out by the return of the Jubilee, was a useful and practical one. It supplied, in fact, all that the Hebrews, in that age, required for the purposes of their calendar. The Babylonian basic number, 60, would have given, as will be seen from the table in the last chapter, a distinctly less accurate correspondence between the month and the tropical year. There is another way of looking at the regulations for the Jubilee, which brings out a further significant relation. On the 10th day of the first month of any year, the lamb was selected for the Passover. On the 10th day of the 7th month of any year was the Great Day of Atonement. From the 10th day of the first month of the first year after a Jubilee to the next blowing of the Jubilee trumpet on the Great Day of Atonement, was 600 months, that is 50 complete lunar years. And the same interval necessarily held good between the Passover of that first year and the Feast of Tabernacles of the 49th year. The Passover recalled the deliverance of Israel from the bondage of Egypt, and in like manner, the release to be given to the Hebrew slave at the year of Jubilee was expressly connected with the memory of that national deliverance. For they are my servants, which I brought forth out of the land of Egypt, they shall not be sold as bondmen. The day of Jubilee fell in the middle of the ecclesiastical year. From the close of the year of Jubilee, that is to say, of the ecclesiastical year in which the freeing, both of the bondmen and of the land, took place, to the next day of Jubilee was 48.5 solar years, or, as seen above, 600 lunations, or 50 lunar years, so that there can be no doubt that the period was expressly designed to exhibit this cycle, a cycle which shows incidentally a very correct knowledge of the true lengths of the lunation and solar year. This cycle was possessed by no other nation of antiquity, therefore the Hebrews borrowed it from none, and since they did not borrow the cycle, neither could they have borrowed the ritual with which that cycle was interwoven. That the Hebrews possessed this knowledge throws some light upon an incident in the early life of the prophet Daniel. In the 3rd year of the reign of Jehoiakim king of Judah came Nebuchadnezzar king of Babylon unto Jerusalem, and besieged it. And the king spake unto Ashpenaz the master of his eunuchs, that he should bring certain of the children of Israel, and of the king's seed, and of the princes, children in whom was no blemish, but well favored, and skillful in all wisdom, and cunning in knowledge, and understanding science, and such as had ability in them to stand in the king's palace, and whom they might teach the learning and the tongue of the Chaldeans. Now among these were of the children of Judah, Daniel, Hananiah, Mishael, and Azariah, unto whom the prince of the eunuchs gave names, for he gave unto Daniel the name of Belteshazzar, and to Hananiah, of Shadrach, and to Mishael, of Meshach, and to Azariah, of Abednego. As for these 4 children, God gave them knowledge and skill in all learning and wisdom, and Daniel had understanding in all visions and dreams. Now at the end of the days that the king had said he should bring them in, then the prince of the eunuchs brought them in before Nebuchadnezzar. And the king communed with them, and among them all was found none like Daniel, Hananiah, Mishael, and Azariah, therefore stood they before the king. And in all matters of wisdom and understanding, that the king inquired of them, he found them 10 times better than all the magicians and astrologers that were in all his realm. The Hebrew children that King Nebuchadnezzar desired to be brought were to be already possessed of knowledge, they were to be further instructed in the learning and tongue of the Chaldeans. But when the 4 Hebrew children were brought before the king, and he communed with them, he found them wiser than his own wise men. No account is given of the questions asked by the king, or of the answers made by the 4 young Hebrews, so it is merely a conjecture that possibly some question bearing on the calendar may have come up. But if it did, then certainly the information within the grasp of the Hebrews could not have failed to impress the king. We know how highly the Greeks esteemed the discovery by Meton, in the 86th Olympiad, of that relation between the movements of the sun and moon, which gives the cycle of 19 years, and similar knowledge would certainly have given King Nebuchadnezzar a high opinion of the young captives. But there is evidence, from certain numbers in the book which bears his name, that Daniel was acquainted with lunisolar cycles which quite transcended that of the Jubilees and preciseness, and indicate a knowledge such as was certainly not to be found in any other ancient nation. The numbers themselves are used in a prophetic context, so that the meaning of the whole is veiled, but astronomical knowledge underlying the use of these numbers is unmistakably there. One of these numbers is found in the 8th chapter. How long shall be the vision concerning the daily sacrifice, and the transgression of desolation, to give both the sanctuary and the host to be trodden under foot? And he said unto me, unto 2,300 days, then shall the sanctuary be cleansed. The 12th chapter gives the other number, but in a more veiled form, and I heard the man clothed in linen, which was upon the waters of the river, when he held up his right hand and his left hand unto heaven, and swear by him that liveth for ever that it shall be for a time, times, and an half, and when he shall have accomplished to scatter the power of the holy people, all these things shall be finished. The numerical significance of the time, times and an half, or, as it is expressed in the 7th chapter of Daniel, until a time, and times, and the dividing of time, is plainly shown by the corresponding expressions in the Apocalypse, where a time and times and half a time would appear to be given elsewhere both as 40 and 2 months, and 1,260 days. 42 conventional months, that is of 30 days each, make up 1,260 days, whilst 3.5 conventional years of 360 days, that is 12 months of 30 days each, make up the same period. The word times is expressly used as equivalent to years in the 11th chapter of Daniel, where it is said that the king of the north shall come on at the end of the times, even of years, with a great army and with much substance. Then, again in the vision which Nebuchadnezzar had previous to his madness, he heard the watcher and the Holy One cry concerning him, Let his heart be changed from man's, and let a beast's heart be given unto him, and let 7 times pass over him. It has been generally understood that the 7 times, in this latter case meant 7 years. The time, times and an half, are obviously meant as the half of 7 times. The two numbers, 2,300 and 1,260, whatever be their significance in their particular context in these prophecies, have an unmistakable astronomical bearing, as the following table will show. 2,300 solar years equals 840,057 days, 1 hour. 28,447 lunar months equals 840,056, 16 hours. Difference equals 9, 1,260 solar years equals 460,205, 4, 15,584 lunar months equals 460,204, 17, difference equals 11, if the one number 1,260 stood alone. The fact that it was so close a lunar cycle might easily be ascribed to a mere coincidence. 7 is a sacred number, and the days in the year may be conventionally represented as 360. Half the product of the two might, perhaps, seem to be a natural number to adopt for symbolic purposes. But the number 2300 stands in quite a different category. It is not suggested by any combination of sacred numbers, and is not veiled under any mystic expression. The number is given as it stands, 2300. But 2300 solar years is an exact number, not only of lunations, but also of animalistic months. The animalistic month is the time occupied by the moon in traveling from its perigee, that is its point of nearest approach to the earth, round to its perigee again. For the moon's orbit round the earth is not circular, but decidedly elliptical, the moon being 31,000 miles nearer to us at perigee than it is at apogee, its point of greatest distance. But it moves more rapidly when near perigee than when near apogee, so that its motion differs considerably from perfect uniformity. But the period in which the moon travels from her perigee round to perigee again is 27 days, 13 hours, 18 minutes, 37 seconds, and there are in 2300 solar years almost exactly 30,487 such periods or animalistic months, which amount to 840,057 days, 2 hours. If we take the mean of these three periods, that is to say 840,057 days, as being the cycle, it brings into harmony the day, the animalistic month, the ordinary month, and the solar year. It is from this point of view the most perfect cycle known. Dr. H. Grattan Guinness, 343:1, has shown what a beautifully simple and accurate calendar could have been constructed on the basis of this period of 2,300 years. Thus, 2,300 solar years contain 28,447 synodic months, of which 847 are intercalary, or epoch months. 2,300 years are 840,057 days. 13,800 non-intercalary MTHS. Of 29D each equals 400,000 227,600 13,800 non-intercalary MTHS. Of 30D each equals 414,423 intercalary months. Of 30 days each equals 12,690 847 424 intercalary months. Of 31 days each equals 13,144 23 days additional for the 23 centuries equals 23. 840,057. The Jewish calendar on this system would have consisted of ordinary months, alternately 29 and 30 days in length. The intercalary months would have contained alternately 30 or 31 days, and once in every century one of the ordinary months would have had an additional day. Or, what would come to very much the same thing, this extra day might have been added at every alternate jubilee. By combining these two numbers of Daniel, some cycles of extreme astronomical interest have been derived by de Chasseaux, a Swiss astronomer of the 18th century, and by Dr. H. Grattan Guinness, and Drive W. Bell Dawson in our own times. Thus, the difference between 2,300 and 1,260 is 1,040, and 1,040 years give an extremely exact correspondence between the solar year and the month, whilst the mean of the two numbers gives us 1,780, and 1,780 lunar years is 1,727 solar years with extreme precision. But since these are not given directly in the book of Daniel, and are only inferential from his numbers, there seems no need to comment upon them here. It is fair, however, to conclude that Daniel was aware of the Metonic cycle. The 2,300-year cycle gives evidence of a more accurate knowledge of the respective lengths of month and year than is involved in the cycle of 19 years. And the latter is a cycle which a Jew would be naturally led to detect, as the number of intercalary months contained in it is 7, the Hebrew's sacred number. The book of Daniel, therefore, itself proves to us that King Nebuchadnezzar was perfectly justified in the high estimate which he formed of the attainments of the 4 Hebrew children. Certainly one of them, Daniel, was a better instructed mathematician and astronomer than any Chaldean who had ever been brought into his presence. We have the right to make this assertion, for now we have an immense number of Babylonian records at our command, and can form a fairly accurate estimate as to the state there of astronomical and mathematical science at different epochs. A kind of quasi-patriotism has induced some Assyriologists to confuse in their accounts of Babylonian attainments the work of times close to the Christian era with that of many centuries, if not of several millenniums earlier, and the times of Sargon of Agade, whose reputed date is 3800 B.C., have seemed to be credited with the astronomical work done in Babylon in the 1st and 2nd centuries before our era. This is much as if we should credit our predecessors who lived in this island at the time of Abraham with the scientific attainments of the present day. The earlier astronomical achievements at Babylon were not, in any real sense, astronomical at all. They were simply the compilation of lists of crude astrological omens, of the most foolish and unreasoning kind. Late in Babylonian history there were observations of a high scientific order, real observations of the positions of moon and planets, made with great system and regularity. But these were made after Greek astronomy had attained a high level, and Babylon had come under Greek rule. Whether this development of genuine astronomical observation was of native origin, or was derived from their Greek masters, is not clear. If it was native, then certainly the Babylonians were not able to use and interpret the observations which they made nearly so well as were Greek astronomers, such as Eudoxus, Thales, Pythagoras, Hipparchus and many others. But it must not be supposed that, though their astronomical achievements have been grossly, even ludicrously, exaggerated by some popular writers, the Babylonians contributed nothing of value to the progress of the science. We may infer from such a tablet as that already quoted on page 320, when the equinox was observed on the 6th day of Nisan, since there were 6 kasbu of day and 6 kasbu of night, that some mechanical time measure was in use. Indeed, the record on one tablet has been interpreted as noting that the astronomer's clock or clepsydra had stopped. If this be so, then we owe to Babylon the invention of clocks of some description, and from an astronomical point of view, this is of the greatest importance. Tradition also points to the Chaldeans as the discoverers of the Saros, the cycle of 18 years, 10 or 11 days, after which eclipses of the sun or moon recur. The fact that very careful watch was kept every month at the times of the new and of the full moon, at many different stations, to note whether an eclipse would take place, would naturally bring about the discovery of the period, sooner or later. The achievements of a nation will be in accordance with its temperament and opportunities, and it is evident from the records which they have left us that the Babylonians, though very superstitious, were a methodical, practical, prosaic people, and a people of that order, if they are numerous, and under strong rule, will go far and do much. The discovery of the Saros was such as was within their power, and was certainly no small achievement. But it is to the Greeks, not to the Babylonians, that we trace the beginnings of mathematics and planetary theory. We look in vain amongst such Babylonian poetry as we possess for the traces of a Homer, a Pindar, a Sophocles, or even of a poet fit to enter into competition with those of the second rank in the literature of Greece, while it must remain one of the literary mysteries of our time that any one should deem the poetry of the books of Isaiah and Job dependent on Babylonian inspiration. There were 2 great hindrances under which the Babylonian man of science labored: he was an idolater, and he was an astrologer. It is not possible for us in our freedom to fully realize how oppressive was the slavery of mind, as well as spirit, which was consequent upon this twofold superstition. The Greek was freer, insomuch that he did not worship the planets, and did not become a planetary astrologer until after he had learnt that superstition from Chaldea. In learning it he put an end to his scientific progress. But the Hebrew, if he was faithful to the law that had been given to him, was free in mind as well as in spirit. He could fearlessly inquire into any and all the objects of nature, for these were but things, the work of God's hands, whereas he, made in the image of God, having the right of intercourse with God, was the superior, the ruler of everything he could see. His religious attitude therefore gave him a great superiority for scientific advancement. Yet there was one phase of that attitude which, whilst it preserved him from erroneous conceptions, tended to check that spirit of curiosity which has led to so much of the scientific progress of modern times. What, how, and why, are the three questions which man is always asking of nature, and to the Hebrew the answer to the second and third was obvious: it is the power of God, it is the will of God. He did not need to invent for himself the crass absurdities of the cosmogonies of the heathen, but neither was he induced to go behind the appearances of things. The sufficient cause and explanation of all was God. But of the appearances he was very observant, as I trust has become clear in the course of this imperfect review of the traces of one particular science as noticed in Holy Scripture. If he was faithful to the law which had been given him, the Hebrew was free in character as well as in mind. His spirit was not that of a bondman, and Nebuchadnezzar certainly never met anything more noble, anything more free, than the spirit of the men who answered him in the very view of the burning fiery furnace: "O Nebuchadnezzar, we are not careful to answer thee in this matter. If it be so, our God whom we serve is able to deliver us from the burning fiery furnace, and he will deliver us out of thine hand, O king. But if not, be it known unto thee, O king, that we will not serve thy gods, nor worship the golden image which thou hast set up." Footnotes: 343:1, Creation Centered in Christ, page 344. Sun, stand thou still upon Gibeon. Sun, stand thou still upon Gibeon, and thou moon in the valley of Ajalon. To list Book 4 Astronomical Marvels Chapter I Joshua's Long Day, 351:1. Method of studying the record: there are three incidents recorded in Holy Scripture which may fairly, if with no great exactness, be termed astronomical miracles: the long day, on the occasion of Joshua's victory at Beth-horon; the turning back of the shadow on the dial of Ahaz, as a sign of King Hezekiah's recovery from sickness; and the star which guided the wise men from the east to the birthplace of the Holy Child at Bethlehem. As astronomy has some bearing on each of these three remarkable events, it will be of some interest to examine each of them from the point of view of our present astronomical knowledge. It does not follow that this will throw any new light upon the narratives, for we must always bear in mind that the Scriptures were not intended to teach us the physical sciences. Consequently we may find that the very details have been omitted which an astronomer, if he were writing an account of an astronomical observation, would be careful to preserve. And we must further remember that we have not the slightest reason to suppose that the sacred historians received any supernatural instruction in scientific matters. Their knowledge of astronomy therefore was that which they had themselves acquired from education and research, and nothing more. In other words, the astronomy of the narrative must be read strictly in the terms of the scientific advancement of the writers. But there is another thing that has also to be remembered. The narrative which we have before us, being the only one that we have, must be accepted exactly as it stands. That is the foundation of our inquiry. We have no right to first cut it about at our will, to omit this, to alter that, to find traces of 2, 3, or more original documents, and so to split up the narrative as it stands into a number of imperfect fragments, which by their very imperfection may seem to be more or less in conflict. The scientific attitude with regard to the record of an observation cannot be too clearly defined. If that record be the only one, then we may accept it, we may reject it, we may be obliged to say, we do not understand it, or, it is imperfect, and we can make no use of it, but we must not alter it. A moment's reflection will show that a man who would permit himself to tamper with the sole evidence upon which he purports to work, no matter how profoundly convinced he may be that his proposed corrections are sound, is one who does not understand the spirit of science, and is not going the way to arrive at scientific truth. There is no need then to inquire as to whether the 10th chapter of the book of Joshua comes from 2 or more sources. We take the narrative as it stands. And it is one which has, for the astronomer, an interest quite irrespective of any interpretation which he may place upon the account of the miracle which forms its central incident. For Joshua's exclamation, "Sun, stand thou still upon Gibeon, and thou, moon, in the valley of Ajalon," implies that, at the moment of his speaking, the two heavenly bodies appeared to him to be, the one upon or over Gibeon, the other over the valley of Ajalon. We have therefore, in effect, a definite astronomical observation, interesting in itself, as being one of the oldest that has been preserved to us, doubly interesting in the conclusions that we are able to deduce from it. The idea which has been most generally formed of the meaning of Joshua's command, is, that he saw Gibeon in the distance on the horizon in one direction with the sun low down in the sky immediately above it, and the valley of Ajalon in the distance, on the horizon in another direction, with the moon low down in the sky above it. It would be quite natural to associate the sun and moon with distant objects if they were only some 5 or 6 degrees high. It would be rather straining the point to do so if they were more than 10 degrees high, and if they were 15 or more degrees high, it would be quite impossible. They could not be both in the same quarter of the sky, both rising or both setting. For this would mean that the moon was not only very near the sun in the sky, but was very near to conjunction, in other words, to new moon. She could, therefore, have only shown a slender thread of light, and it is perfectly certain that Joshua, facing the sun in such a country as southern Palestine, could not possibly have perceived the thin pale arch of light, which would have been all that the moon could then have presented to him. Therefore the one must have been rising and the other setting, and Joshua must have been standing between Gibeon and the valley of Ajalon, so that the two places were nearly in opposite directions from him. The moon must have been in the west and the sun in the east, for the valley of Ajalon is west of Gibeon. That is to say, it cannot have been more than an hour after sunrise, and it cannot have been more than an hour before moonset. Adopting therefore the usual explanation of Joshua's words, we see at once that the common idea of the reason for Joshua's command to the sun, namely, that the day was nearly over, and that he desired the daylight to be prolonged, is quite mistaken. If the sun was low down in the sky, he would have had practically the whole of the day still before him. 2. Before the battle. Before attempting to examine further into the nature of the miracle, it will be well to summarize once again the familiar history of the early days of the Hebrew invasion of Canaan. We are told that the passage of the Jordan took place on the 10th day of the first month, and that the feast of the Passover was held on the 14th day of that month. These are the only two positive dates given us. The week of the Paschal celebrations would have occupied the time until the moon's last quarter. Then preparations were made for the siege of Jericho, and another week passed in the daily processions round the city before the moment came for its destruction, which must have been very nearly at the beginning of the second month of the year. Jericho having been destroyed, Joshua next ordered a reconnaissance of Ai, a small fortified town, some 20 miles distant, and some 3,400 feet above the Israelite camp at Gilgal, and commanding the upper end of the valley of Acre, the chief ravine leading up from the valley of the Jordan. The reconnaissance was followed by an attack on the town, which resulted in defeat. From the dejection into which this reverse had thrown him, Joshua was roused by the information that the command to devote the spoil of Jericho to utter destruction had been disobeyed. A searching investigation was held. It was found that Achan, one of the Israelite soldiers, had seized for himself a royal robe and an ingot of gold. He was tried, condemned and executed, and the army of Israel was absolved from his guilt. A second attack was made upon Ai, the town was taken, and the road was made clear for Israel to march into the heart of the country, in order to hold the great religious ceremony of the reading of the law upon the mountains of Ebal and Gerizim, which had been commanded them long before. No note is given of the date when this ceremony took place, but bearing in mind that the second month of the year must have begun at the time of the first reconnaissance of Ai, and that the original giving of the law upon Mount Sinai had taken place upon the third day of the third month, it seems most likely that that anniversary would be chosen for a solemnity which was intended to recall the original promulgation in the most effective manner. If this were so, it would account for the circumstance, which would otherwise have seemed so strange, that Joshua should have attacked two cities only, Jericho and Ai, and then for a time have held his hand. It was the necessity of keeping the great national anniversary on the proper day which compelled him to desist from his military operations after Ai was taken. We are not told how long the religious celebrations at Shechem lasted, but in any case the Israelites can hardly have been back in their camp at Gilgal before the third moon of the year was at the full. But after their return, events must have succeeded each other with great rapidity. The Amorites must have regarded the pilgrimage of Israel to Shechem as an unhoped-for respite, and they took advantage of it to organize a great confederacy. Whilst this confederacy was being formed, the rulers of a small state of Hivites, by which we must understand a community differing either in race or habits from the generality of their Amorite neighbors, had been much exercised by the course of events. They had indeed reason to be. The last conquest of Israel, was less than 4 miles, as the crow flies, from Beer, which is usually identified with Beeroth, one of the 4 cities of the Hivite state, and the Beerothites had, without doubt, watched the cloud of smoke go up from the burning town when it was sacked, and the mound which now covered what had been so recently their neighbor city, was visible almost from their gates. That was an abject lesson which required no enforcement. The Hivites, sure that otherwise their turn would come next, resolved to make peace